So I just started the recording. We're going to get started with this session, which is the Contributed Papers in Archaeology 2. Welcome, everyone. We're going to start off our series of presentations with Lorena Medina Martínez, who will be presenting a paper entitled Spanish Identity Through the Material Remains of the First Cathedral of New Spain. So Lorena, you should be able to share your screen and you can start when you're ready.
Can you see my screen?
Yes, I can see your desktop right now.
Okay. Okay.
Looks good.
Okay. You can see the presentation, right?
Yeah, I can see the presentation. Perfect.
Okay. Okay, thank you everybody. And I want to start by thanking the organizers of this, the 49th annual meeting of the Alaska Anthropological Association. And I want to say thank you to all of you that are here today. Okay. I acknowledge that I am presenting this paper for a conference that is being held in the traditional land of the Dene people, past and present, and from the traditional land of the Wamish people of Seattle, past and present. It is with great honor and respect that I recognize your sacred land. Before getting into the topic, I want to start mentioning some of the terms that we are really used to. And I think we have to think about them and rethink them and eventually change them. And the first one is Indians. I don't want to use that term. I rather to use indigenous or natives because the term Indian was imposed by Eyre and has been since then a term that historically carries a heavy negative undermined connotation and symbolic racism, classism, and humiliation. For the case of conquistadores or Spanish conquest, I don't like that either. I rather to use invaders because these so-called conquistadores were a group of people that invade a territory that was already occupied by many human groups. And this term can be classified as a meta-narrative, which is a type of storytelling which legitimizes an official history and universal status of truth. The other one is pre-Hispanic, which I don't think is correct either because it's inaccurate to refer a cultural group or to catalog a cultural group taking as a point of reference another totally different cultural group. And the last one is the discovery of America, because the American continent wasn't discovered. The whole territory was already inhabited by human groups with a high cultural development and very integrated political, economic, and social systems. Today, I am presenting the investigation that I did for my master's degree in anthropology with the University of Alaska, Anchorage. My research was on the material remains of the first cathedral of New Spain. I want to mention that without the great support of Diane Hanson, Kristen Olivier, Doug Beltry, and Paul White, and the scholars from INA, National Institution of Anthropology and History in Mexico, this couldn't be possible. Thanks to all. The remains of the Cathedral of New Spain are located in downtown Mexico City that you can see in this map. The capital of New Spain was the capital of the Aztec Empire and was defeated on August 21st, 1521 by a majority of indigenous allies and the Spaniards. I want to clarify or mention that my topic was and is around Spanish identity. That is why I don't cover indigenous issues, but both indigenous and Spaniards had like a really active agency in the Viceroyalty of New Spain. My case of study is temporarily situated from 1523 to 1626, the years that the first cathedral was built and in service. It is important to keep in mind the fact that these Spanish were the first Spaniards in this area in the American continent. The question is, what means to be Spanish or European overseas in a newly known and recently appropriated territory? How these Spaniards deal with the remoteness of Europe and its culture, people, and customs, and how did they accustom themselves to the American continent? Part of the answer is that they brought as much as they could from Europe to reproduce, to make a replica of what was left behind in Europe. And that is what the material remains of the first cathedral, some chronicles of the time, and other movable artifacts and commodities show throughout the investigation. This image is a close-up of a map of Mexico Tenochtitlan from 1550, and this is the representation of this specific building, the first cathedral of New Spain. Spanish identity, as any other identity, was manifested in the material domain through architecture, styles, ornaments, paintings, furniture, Christian, Latin, and other books. In the social sphere, identity was brought in the way people dress, behave, act, how they eat, think, talk, among other aspects. Within archaeology, issues of identity are an important aspect of the human behavior. Social sciences and archaeology approach issues of identity through different aspects, one of them by analyzing how ethnic groups construct cultural boundaries of people that share same cultural background and similar interest, creating cultural and identity ties, and unifying the members of the ethnic group. A tangible form of group's identity is expressed and embedded in different material forms, which fulfill the function of communicate and preserve the group's identity. As Federico Navarrete has said, a collective identity helps to define a political and social community that is called ethnic identity. And here in the image, the slide, what I have is these materials that were found in archaeological excavations in central Mexico City from the 16th century. And we can see this anthropomorphic figure wearing European clothing and showing this European phenotype, sorry. And then the other is just a fragment of Talavera. It is important to bear in mind that the Aztec Empire was the most important, famous, and strong empire and city when the Spaniards arrived. Why is this important? Because the reason why New Spain was built on the same area of Mexico Tenochtitlan had a political and economical reason. It is known that the decision to retake the space of Mexico Tenochtitlan as the capital of New Spain had the intention of inherit the fame and greatness that the Aztec capital had during the Mesoamerican post-classic period. And here what we have is the coat of arms of Hernán Cortés, one of the main invaders, and it was given to him by the King of Spain, Charles V, when Cortés was appointed as governor and capital general of the Kingdom of New Spain in October 1522. Besides the cultural expression that this code gives us, there is this idea of taking over and giving a status and power to the men that had a really important role on the invasion of the new territories for the Spanish crown. In January 1522, Alonso Garcia Bravo and, and indigenous planners planned the center of the capital and began the layout of the streets and squares of New Spain, following the existing grid designed by the Aztecs in the capital of Tenochtitlan. Spaniards wanted, this was their desire, to have this space and make this traza as an exclusive space to reflect this 16th century Spanish identity through elements such as architecture and urbanization to which politic and strategies were added. Here we have this map of Mexico Tenochtitlan in 1550. Maps are really important for many reasons. And in this case, I want to mention, of course, the information that this give us. And that maps in this case are statements, are references, are means of appropriation, declaration, and representation. So we can see the way they represent the city, and we can see its Castilian nomenclature and the conception of the territory and the style of buildings, which are another expression of this identity. And then we have this other map, which is from was in one of the letters that Hernán Cortés sent to Emperor Charles V in 1524. Actually, this was the second letter, and is the representation of Mexico Tenochtitlan through Spanish eyes. Here we can see a representation of Tenochtitlan, part of the Aztec Empire, as early as 1524, some of the building of the Aztec Empire. But as we can see now, they are showing or being represented rather with European elements. The remains of the first cathedral of New Spain are in the subsoil of the atrium of the current Metropolitan Cathedral of Mexico City. There are 4 archaeological windows from which general public can see the material remains of said church. So we can see, I don't know if you see my pointer, but we can see the current Metropolitan and these 4 windows. And in this area of the atrium, the street and the avenue is where the first cathedral is in the subsoil. Here, I am presenting you this plan in which you can see how the Spanish citadel was built on the heart of the Aztec Empire. Here we can see the shared space between Aztec and Spanish buildings. So what we have here, this is the current Metropolitan Cathedral. Here is the first cathedral, or the remains of the first cathedral of New Spain. This is Templo Mayor, which is the main temple of the Aztec capital for Huitzilopochtli and Tlaloc. And here in this street, this is Guatemala Street, and here we have the Zompantli, which is the Skull Tower, Ejeca Temple, and this street is Argentina, and we have another archaeological windows in which we can see other buildings, other constructions, and all over the area in the subsoil, we have a lot of remains of the Aztec capital. One of the most preserved spaces of the first cathedral is this, in which we have decorative and iconographic designs on the tiles of different painted styles, motifs, designs, and colors. This is as well the only space that is visible to us that still has stairs with tiles that are affixed to the racer, embedded in the trace of the steps. In regards to tiles, there are an important diagnostic material due to its high manufacture and transportation costs, which can be traduced to a good indicator of the hierarchy of the space, the building, and the population. Tiles were not accessible to the majority of the population, but only to the high social classes as a sign of prestige. According to archaeological excavations around downtown Mexico City, use of tiles was restricted to building of the highest civil, political, and religious authorities. In regards to the paintings that were hung up in the first cathedral, 5 of them are still preserved in the current Metropolitan Cathedral. These paintings were and are examples of representation that, besides from its liturgical aspect, they exhibit culture, beliefs, and ethnic ties. They show elements of a Central European style, such as facial features, skin tones, movements of fabrics, iconography style, and the choice of colors. Both paintings exemplify the importance of representing Christian beliefs under European aesthetics models, recreating an atmosphere and creating a space similar to Spain. And what we have here is one of the paintings, is the first one, Tobias and San Rafael and Archangel, painted by Martínez, and it looks like it was brought from Spain, from Europe. The other one is the Five Lords, or the Holy Family, and this is no, we don't know if it was brought from Europe or if it was made in New Spain by European artists. And in the middle, what we have is one fragment of a mural that is in the interior wall of the first cathedral, and we can see the phytomorphic designs. And here we have the burial of Canon Miguel de Palomares. He was buried in a grave covered by a tombstone that rests on its upper surface. Here lies Canon Miguel de Palomares, Canon who was one of the first in this holy church, died in 1542. According to the context of the elements, it is believed that the gravestone was part of the floor of the central nave of the first cathedral. Social hierarchies and the sumptuousness of some archaeological materials of the first cathedral of New Spain are represented in this burial. And what we have here are some columns and bases that were found in 1881. This was one of the first archaeological excavations, 1881. And these columns are present day. You can see them in the atrium of the Metropolitan Cathedral of Mexico. They are carved stones taken from the nearby Aztec temples, and they originally have indigenous motifs, but then they were transformed and reused to shape as columns for the first cathedral of New Spain. And I don't know how I am doing in time.
You've got 3 minutes left.
Okay, so I just want to go back here where I didn't mention something. Well, I guess I cannot go back. I think my computer is misbehaving, but okay, I finished. Sorry. Yeah, so that was my presentation. If there is questions or something, please.
Yeah, thank you so much, Lorena. Yeah, if anyone has a question, I think we have time for one question. If someone has a question for Lorena.
Actually, Lorena.
Yeah.
In that last slide, the showing the columns and stuff, are there any preserved images of where those columns came from and how they might have been used in the traditional architecture, or is that just more of a historical note?
Yeah, I think there are some drawings in Kubler. George Kubler is one author, and he has some drawings in his book, Mexican Architecture from 16th Century. And yeah, he has some representation of this first cathedral of New Spain with the columns. Besides that, I guess, yeah, it would be more documents in some archive that eventually I can find. But this basically is what we have.
Right. Thank you so much, Lorena. I'm gonna announce Buster Landin for his next talk. Is the next talk in this session. And Buster, if you want to start sharing your screen, we'll start in another minute to keep us on the schedule, since we have a lot of people coming in right now. All right, so our next talk in this session is by Buster Landin with a talk entitled A Review of the Antiquity and Distribution of Intertidal Fishing Technology in Southeast Alaska and Future Research Inquiry. So take it away, Buster.
Okay, you can hear me fine?
I can hear you, thank you.
Okay, excellent. So thanks for coming. As Hollis said, we're going to take a look at fish weirs in Southeast Alaska. So let's just get going here. So my name in Tlingit is Kanagut. I'm a Raven Coho clan of the Little Coho House, and I'm a child of the Thunderbird clan. Just want to let you know where I'm coming from here. So today's presentation, we're going to take a look at a new storytelling paradigm that I've been developing. We're going to take a look at also the Tlingit and where their current homelands are, and we're going to take a little look at ice humans and the interaction between those two. We're also going to take a look at fish weirs and what they are and how they've been used in the past, how old they are, what they're made out of, and then basically going to take it from there to look at what my current storytelling is and what the future holds for that. So the research paradigm that I've been developing is called Ha'a'u'u. It means our sacred clan items. And so through traditional Tlingit concepts, A'u is this community owned sacred object that can be anything, essentially a clan name, not only of the clan themselves, but a person's name. So like Kanagut is part of the clan. The clan owns that name. So when somebody passes away, that name returns back to the clan and they can reuse it. So this also entails, songs, dances, regalia, place names, and most importantly, salmon creeks or rivers. Another part of A'u, as we're getting into it, I'm using it to bypass and circumvent the historical extractive nature of the interaction between colonial powers and their fields of anthropology and archaeology with the indigenous people. It should come as no surprise that entwined with that is the language that's used in anthropology that reflects the power imbalance inherent in the European American systems set up in the United States and in academia. Simply put, I'm trying to change how archaeology uses our archaeological and historical how archaeology in some instances uses our history versus their history, and I'm trying to through my research, and actually that comes to another point. I don't use the word research as well, because that's also part of the extractive history of archaeology. So I use a more traditional paradigm of storytelling. So I listen to elders, I observe, and I basically take this information and tell a new story. Using this Tlingit approach and worldview, And so, that's how I'm going to approach this research. And I thought it was interesting enough to, to highlight that point and bring it up, at this, with this presentation today. So here's a quick look at the Tlingit homelands, highlighting the clan areas in Southeast Alaska. Gives you, just a real quick, a lot of people understand, being from Alaska, know where, the Tlingit homelands are. So this slide, we're looking at the last glacial maximum at approximately 20,000 years ago, which is illustrated by the greenish area. You can see my cursor. And the orange area indicates the late Wisconsin glacial extent. I have highlighted also the new female grouse fort area, which is people are familiar with Groundhog Bay site close to Excursion Inlet, and Shukaka, where his remains were found down there. But also we're taking, because of that, we're looking at icy straits and when it was deglaciated at approximately 13,500 years ago. So we're looking at the time frame between the last glacial maximum and when you get to these really early human inhabitants coming into Southeast Alaska. So with Groundhog Bay or New, that's about 10,180 years ago. Artifacts have been dated to, or I should say radiocarbon dated to approximately that. And Shukaka, a little bit later from there. And so, these are some of the oldest known sites in Alaska. And so we're trying to establish a timeline between when the glaciers were there, when first human habitation started to occur in Southeast Alaska, and taking a look then at, the fish weirs that, so before we get there, we're going to take a look at what a fish weir is. It is a fish catching technology that is passive, static, highly adaptable. Oh, I'm sorry. Hit the wrong button. Do I have to go back out of this?
No, you can see on, if you can see from current slide is an option there for you. Hit that one.
Okay. I don't know what button I hit here. Okay, so it's a passive, static, highly adaptable structure that is primarily composed of linear to curvilinear wall-like mounds of rocks 2 to 3 feet high and approximately 2 to 3 feet wide at the base. Sometimes these stone fish weir systems were built in conjunction with fence-like wooden structures. And, so we kind of give you an idea that, they're also fairly large. You look at the limbs of this one fish weir that was in Frederick Sound and measured 40-meter arm length, a 37-meter chute of 7 meters. So they're by any means not small. I feel that it's a really strong indicator of permanent settlement, and the reason why we think that is a strong indicator, is just look at how much work would be involved in creating that fish weir. So for this fish weir here, we're talking approximately 43 cubic meters of cobble-sized rocks needed to create that fish weir, which in turn is about 112 metric tons of materials that would have been moved by hand. And to put that in another perspective, it's about 5,000 50-pound loads of material to carry out into the intertidal flats. So, it is a huge time investment for people. And so you in order to want to put that much time and effort, you would definitely want to be sticking around for a significant period of time. So with that, then we're looking at the oldest current known fish weir is about 5,500 years old in this area. And so, from this work, I borrowed from Smith. This was her map that she made, with, kind of detailing what was the most current review of fish weirs in Southeast Alaska. And at that time, there was approximately, 111 dated fish weirs and 369 not dated fish weirs. And to give another perspective on this is we're looking at the clan areas and the fish weirs. So you kind of see where some of the fish weirs have been concentrated and where they're seen today. So let's take a look here at the ages from some of these fish weirs, and I have highlighted the 5,500 year old one that we have, and the orange ones are the next oldest dated ones. From there, it goes all the way up to contact with colonizers. So and there's no concentration here. You don't, it's a good distribution of the ages spread out through the region, but there's a very small amount of dated fish weirs in Southeast Alaska to really see if there's any clustering or anything like that that would indicate a point of origin that would show a spot for fish weir technology to spread throughout Southeast Alaska. This is a map that I constructed of the types of fish weirs that are found in Southeast Alaska. This is all of them, dated and undated. You can definitely see a concentration of the purple or pinkish ones, which are stone fish weirs, and those really tend to be, as seen from this illustration, down in the southern part of Southeast Alaska, where a little bit further north, the green squares, you're starting to see the wooden stake types of fish weirs. And you have a small spattering of what I've come to term dual stone and wooden stakes, wooden stake fish weirs, which is a combination of the two. So of the two types of fish weirs, you have stone fish weirs, but then over top of some of them, it's like superimposed wooden stake style fish weirs. So I called those dual fish weir sites. And then you have what I called hybrid sites, which, you have the stone fish weirs in the same alignment as a wooden stake fish weir. So they're used in conjunction, right as one whole fish weir. So I call that kind of a hybrid design. Of course, then there's some unknown, but and the highlighted one is close to where the oldest fish weir site is. So when you take into account the oral traditions of the Tlingit and how they describe their journey into Southeast Alaska, the Tlingit recount their journey to the south through the mountains from the central interior of Alaska and the main group of Athabascan speaking people that are still found there today. And they journeyed south through the mountains into the area near the Nass and Skeena River valleys that eventually they followed through and ended up on the Pacific coast. And through that oral tradition, they found that the Raven clans were already there. And so when the entire group was there, then they began to move north. And it's interesting to think about, as the stone fish weirs might be considered, just the oldest ones. And this is interesting because that would also follow with how the journey of the Tlingit into Southeast Alaska, moving north from basically Prince Rupert, British Columbia, and moving north, and they would come into these areas. So here we just trying to go quick here. We're taking this information that we have now, we're building some LiDAR terrain models to look at paleo sea levels and stream channels in order to try to locate likely areas where older fish weirs could be located. As many people know, Southeast Alaska has been very geologically active with isostatic rebound, and you also have a subduction zone that has also lifted up parts of the area above sea level. And the reason why that is an interesting look is because there is an approximately 8,000 year gap between when ice was off and then when people first started showing up, and then to the oldest fish weir. So there was plenty of time for other people to come into this area. And so we're going to use GIS to create this model, and hopefully this will point us to areas that we can look into to find those. And as future research is continued with GIS, basically trying to find information on whether we can use stone fish weirs as a proxy for older fish weirs, finding out how that technology spread throughout the area, and also something that we're really hoping to be able to do in the future is to look at salmon species and do DNA samples from them to see if we can do relative abundance of different salmon species, and build a population model that would help with fisheries managers today. And finally, we're just can continue using the methodology to listen and to gain insights from the Tlingit into this technology and how it was used.
Great.
So that's pretty close.
Yeah.
Is there any
Perfect.
question? Dead on? Any questions? Sorry.
I think if folks have questions for Buster, maybe hold them until our first break so we can keep ourselves on schedule here. But thank you so much, Buster. That was a wonderful presentation. And I am really excited about your use of storytelling as a framing for your, I don't want to say research, but you know, you know what I'm saying.
Yeah, the use of storytelling in archaeology and anthropology, you know, as opposed to, you know, the extractive nature of research. So yeah.
Right. Perfect. Thank you so much. All right. So now we get to the dangerous part where I am both the moderator and the presenter. So someone else keep an eye on my time, please. So I am going to share my screen. And hopefully that looks all right. So Shamai, everyone, welcome. My name is Hollis Miller. I'm a PhD candidate in anthropology at the University of Washington in Seattle. And before I jump into my presentation entitled Learning from Nunamiut, Fieldwork and Storytelling at the Inuk Site, Sipilitic Island, I would like to take a moment to respectfully acknowledge that I'm presenting from the homelands and waters of the Duwamish, Suquamish, Muckleshoot, Tulalip, and other Lushootseed speaking peoples who remain living in and connected to this place that we now call Seattle. Ooh, I've got the other added bonus here of being the person that has to admit people into the room while I'm presenting. Okay, this is all going to be great. Today I'm going to be talking about the 2021 fieldwork at the Inuk site, which is located on Sipilitic Island in the Kodiak Archipelago. Inuk is in the Old Harbor region of Kodiak and was excavated as part of the Old Harbor Archaeological History Project. The project is a community-based archaeology project run through the University of Washington with support and collaboration from the Old Harbor Native Corporation and the Alutiiq Tribe of Old Harbor. So zooming in on Kodiak here, you can get a sense of where Old Harbor is. You can see it located on the southern side of the archipelago. It's one of 7 native villages around Kodiak and has a current population of around 200, 250 people. It grows in the summer when people come home for the fishing industry. And people in Old Harbor today primarily find work in the fishing industry in local and regional service organizations or governments, or in the tourism and sport hunting and fishing industry. And just as their ancestors have for millennia, Sugpiaq people in Old Harbor harvest a bounty from the highly productive waters of the Gulf of Alaska, especially from their rich salmon streams, which spawn all 5 types of Pacific salmon. That strong relationship with these homelands and waters is part of what it means to be Sugpiaq today. I've built a relationship with this community over the past 5 years and developed the archaeological research that you'll hear about in this talk in partnership with Old Harbor in order to meet their needs and also my interests as a scholar. Part of doing this work is establishing relational accountability, and that is relationships built on trust and mutual respect. Those relationships only come about when people get to know one another, not just as researchers, but as people or as storytellers, perhaps, as Buster would say. So I've spent many days in people's kitchens in Old Harbor, sipping endless cups of tea and talking story to learn about people and their interests and experiences, while also opening up myself to be known. And I just want to take a quick moment here to honor and remember Mary Hawkinson, who's pictured here. Mary passed away in November, and that's been a great loss to the community. But I'm really, really honored to have been able to know Mary and spend time with her. I was supposed to show this slide during the last bit I said. Sorry about that. But moving along, A key term that I think about in my research is survivance, which is a concept defined by Anishinaabe scholar Gerald Visner as an active sense of presence and continuance of native stories. Survivance has emerged as an important intervention within studies of settler colonialism, especially in North America. Survivance decenters colonial narratives of victimhood and instead refocuses attention on how Indigenous peoples responded purposefully to colonial circumstances and ultimately have survived and continue to survive and thrive in the face of colonialism in settler nations like the United States and Canada. Survivance is especially important in countering dominant narratives that have circulated and continue to circulate about Native folks in North America, damaging narratives such as the ecological Indian, the noble savage, or even the idea that Native folks aren't around anymore or are stuck in the past. So I argue that as a settler scholar who works with Indigenous communities to learn about colonialism, that storytelling with community is especially important because it forces me, letting people in the room, because it forces me to center those colonial narratives of Native passivity and stasis and instead tune into the stories of Native survivance. Storytelling also allows us to explore the diversity of ancestors that we encounter through archaeology and history. Those ancestors had thoughts, dreams, emotions, differences of opinion, and different responses to colonialism. So I'm going to give a brief overview here of the Old Harbor Archaeological History Project, which is what I'm working on for my dissertation. Our driving question is about how Sugpiaq communities navigated Russian colonialism in the Kodiak Archipelago and in Alaska. The time period that we are looking at here is the mid-1700s, when Russians first invaded Alaska until 1867, when Russia sold Alaska to the United States. Some key challenges that Sugpiaq people faced during this period were direct violence, such as a massacre at Awauk near Old Harbor in 1784, introduced disease like smallpox, to which Native folks had no built-up immunity, forced labor when most men were removed from the island for half of the year in order to hunt sea otters and other fur-bearing mammals as far away as California, Hawaii, and the Kuril Islands, while women were left in Kodiak to care for their families and meet Russian demands for local labor. And also, finally, forced resettlement, when Sugpiaq people were forced to leave their ancestral villages and resettle in places where the Russians had set up labor stations or administrative centers. So I specifically examined through this project how daily life and daily practice happened at Inuk, at a Sugpiaq village, in the face of those challenges that were brought by Russian colonialism. Focused especially around these three areas: foodways, labor, and residence. Thinking about practice around food, everything from harvesting through disposal. What kinds of work or labor are people doing, both at the demand of Russian American company and for their own households? And how are Sugpiaq folks maintaining their houses and managing ceremonial practices? And I further asked how this experience might have been gendered or aged. And I explore those questions using archaeology, ethnohistory, and oral history. So, this is the Inuk site, an overview here. The site itself is along this beach berm right here. Inuk was occupied prior to Russian arrival until about the year 1840. The radiocarbon dates are not back yet, although we expect some of them to come back modern. So we don't know when Inuk was first occupied, but artifact types don't indicate any occupation earlier than the Koniag tradition, and maybe about 400 years old at most. Inuk is a village with about 10 houses and one ceremonial space called a kaski. The ceremonial space is this structure that's actually behind the beach berm. In the summer of 2021, our field team excavated half of a sod house or chikua at Inuk, as well as the upper layers of the associated midden. So here's a view looking straight down at the site. This is we hadn't finished our excavations for 2021 yet there, but this is the house that we excavate. Over here is the koski, the ceremonial space. The water is up, so towards the beach is up on this image. Beads that we collected from Inuk in 2021 helped with dating the last occupation of the site. The style of the beads we found matches the assemblage found by Aaron Kroll at the Three Saints Bay site, which was the earliest Russian occupation of Kodiak. All the beads were found in the two uppermost levels of the excavation. So we can say that Sukpiak ancestors last lived at Inuk during the early Russian colonial period, which matches up with the documentary record that we have of the site. And here are some of the other artifacts and animal remains that we found at Inuk, including sea mammal bones, a stone lamp, and numerous ulus and other ground slate tools. We also found a lot of local ceramics at Inuk, which was very exciting, including this mostly complete pot used for the hot rendering and storage of sea mammal oil. This is a relatively rare find in Kodiak because local pottery is quite crumbly once it's been buried. And this is the second most complete pot that the Alutiiq Museum has in their collections now. So we are very excited to contribute there. In situ, you can see the pot nestled in the ground near a slate-lined hearth. This pot was purposefully dug into the ground by its users rather than simply resting on the house floor. With this proximity to the hearth, you can imagine Sukpiak chefs preparing meals over the hearth and scooping sea mammal oil out of the storage pot into their cooking vessels, much as many of us might keep a bottle of olive oil or something similar next to our stoves today. Taking these artifacts and features together in context gives us snapshots of ancestral life and activities at Inuk. A midden was another big excavation area for us at Inuk this past summer. You can see Miranda LaZar there in the front, who will be presenting later in this session, and Larissa Fitzhugh in the back. Inuk has several well-preserved middens, and we excavated a 2x2 meter block in the midden associated with the house that we were also excavating. The deposits were very rich, and we came back to Seattle with 700 pounds of material from not that much digging. Given the richness of the midden, we were not able to excavate to the bottom, which we estimate to extend for at least another meter in depth. The sorting and analysis of midden materials is still ongoing in the lab, so I can't quantify things for you at the moment, but I can give you my initial observations. We're finding that the midden is dominated by invertebrates and fish, with modest amounts of bird bones and a few mammals, all sea mammals. Invertebrate species represented in the midden are readily available in the intertidal zone in front of the site, such as blue mussels, cockles, whelks, chitons, butter clams, and limpets. The fish are mostly cod and salmon, although we also are finding some halibut and rockfish. We haven't tried to ID any birds yet, but for mammals, we've ID'd so far, all of them are marine mammals, most commonly the northern fur seal, plus a few harbor seal elements and porpoise, which is very rarely noticed, but we've got a porpoise ear bone up here on this slide. It's one of the things that took me forever to figure out what it was, but that was exciting to find. So that was the midden that's out in front of the house. There is also a midden that is buried underneath the hearth of the house. You can see here in profile, these first layers is the hearth, and then the upper floors of the house that we were excavating. And then underneath that, we get this really, really rich midden deposit, which we also sampled. And this indicates earlier use of the landscape, the beach berm, before the house was built, or at least before it was in its current formation. And this midden is distinct from the main midden in its composition, where here fish are dominant while also containing northern fur seal remains. You can see some vertebra here right in the wall. And there's virtually no shellfish or bird remains here.
No, I'm not. I'm waiting till 11:40.
Sorry.
To listen to
Mike,
somebody something.
you're not
Oh,
muted.
Fran at 11:40.
Sorry, I'm trying to mute folks here. Zoom problems. So, preliminary Inuk stories. What stories are beginning to emerge from the archaeological data? What stories are Nunamiut, or the people of Inuk, telling us? From the Midden, we are beginning to see that Sugpiaq ancestors harvested foods more locally during the colonial period. There's a wider breadth of foods found in the Midden associated with the house, with a dominance of shellfish. This might be because men were removed from communities at high rates, some never to return, and those left behind, which were predominantly women, children, and elders, struggled to make ends meet while also bearing their own labor demands from the Russian colonizers and dealing with the massive loss of relatives to violence, disease, and removal. There was neither the time nor the people power to go far from the village to harvest food, so people ate what they could harvest locally, mostly intertidal foods, plants, birds, and fish from the near shore or the salmon stream located just down the beach. This is in contrast to their ancestors whose earlier use of Inuk, as shown in the buried midden under the house, shows access to predominantly offshore foods like cod, halibut, and migrating northern fur seals. Glass beads were the only trade goods found at Inuk. Does that mean that Nunamiut were selective in the goods that they accepted from the Russians, choosing only those that they could incorporate into existing lifeways and crafts? That's a question that's still open, but interesting that those are the only trade goods available that we found at the site. The ubiquitous presence of locally made pottery suggests that Nunamiut continued to make and use pots for cooking and storage into the 1830s, rather than adopting metal or tradeware vessels, which are found at other nearby sites of similar age. Pottery was likely made by the women of Inuk, and its continued presence suggests that intergenerational knowledge continued to be shared among the women and girls of Inuk, even after the devastating attacks on Sugpiaq people by Russian fur traders like Shelikov and Baranov. Sugpiaq people persevered. Cultural knowledge can be a balm in times of disaster, a way to make do and make it through. These are the stories that I'm starting to hear from Nunamiut ancestors, and I hope that they are willing to share more as I continue studying the artifacts and fauna. While I'm working to understand Sugpiaq responses to colonialism using archaeological methods and analysis, my collaborators in Old Harbor are building from the archaeology to create parallel interpretations. Alison Pesterkoff has written a short story called Kichak that tells the story of Nunamiut as they faced Shelikov's arrival to Kodiak and Siklitic Island, what would become known as the Awalk Massacre. As a Sugpiaq woman from Old Harbor, Alison draws on place-based and cultural knowledge to bring the village and its people to life from the perspective of a young Sugpiaq woman named Kichak. Tamara Swenson, an artist from Old Harbor and a 2021 intern in the field this summer, is now creating visual reconstructions of the house that we excavated at Inuk. Her art provides yet another interpretation of the data and the stories here. We braid all of these interpretive methods together to tell the stories of Sugpiaq ancestors at Inuk. This creates a more robust, accessible, and inclusive practice of historical research, one that is grounded in place in Old Harbor, tethering Nunamiut to their descendants, the Nunamiut, or the people of Old Harbor today. So thank you very much, Fiana Shinak. I'm deeply honored to be able to work on the Old Harbor Archaeology History Project, and I want to especially acknowledge these specific Old Harbor community members listed on the first bullet point. I am also very grateful for the support of the National Science Foundation, the Quaternary Research Center, and the Center for American Indian and Indigenous Studies at the University of Washington in funding this research. And also shout out, since many of you are watching, thank you so much to all the field and lab team members that have been a part of this project. So now I have to make the awkward transition. Let's see.
That was an awesome presentation, Hollis. Thank you.
Thank you,
Just
Kelly.
a side note to remind everyone to please mute. Mike, I think you're unmuted.
Yeah. Thank you. Yes, thank you for that, Kelly. With everything up, like me being the host, I was admitting people, I was trying to figure out how to mute people, I was trying to give my presentation. So that was a lot, but we made it through.
Yeah, your multitasking was very impressive.
Thank you, thank you. So I need to make our next presenter the co-host. Is that going to be Kathryn, Fran, and Angela? Would all of you need access?
Please, yeah. Sharing on my other profile. I know it looks like it's complicated, but my other profile needs the screen sharing capability.
Okay. Katie, I see you first. You're going on as co-host. All right.
And I'll just
Angie Wade without the typo after your name. That's the one.
Yes,
okay.
That's the one.
Got it. And Fran. Is Fran sharing her screen?
Yep.
Okay. Well, then actually she doesn't need to be co-host. It'll be perfect. Great. So I've already kind of introduced them, but let me officially introduce Kathryn Krasinski, Fran Seager-Boss, and Angela Wade for their presentation, Community Archaeology in the Matanuska Watershed.
All right. Thanks. Yeah, Fran's with us. Apparently she's a hot commodity, but who can blame whoever that wasn't on mute? She's pretty special to us too. I'm Angela Wade. I am a Chickaloon Village tribal citizen. I am reporting to you from Chickaloon Village lands. I can see the place where my grandmother speared her first fish when she was 5 from my deck. So grounded in place I am, and that's my responsibility. I am presenting to you today community archaeology in the Matanuska Watershed, which is some of our homelands. With us, I want to recognize Fran and my Aunt Rain, who may or may not be here. They are integral to our project, and also to Dr. Kathryn Krasinski, who is amazing, and we chose to work with her. I chose to work with her years ago on we were on a project that had all these amazing features, and I just quietly went and sat down on a promontory above a river and wanted to just feel the place. And Katie was smart enough to just come and sit next to me quietly. And then eventually when I started to stir, she said, "What do you feel?" And I was like, that's the person I want to work with, because she understands there's alternative ways of knowing in place. So that's really important. Go ahead, Katie, take it away.
Thanks so much, Angie. And also we just want to thank the conference organizers, session organizers, and the presenters for today. You've been amazing. And Hollis for doing all of the computer work. Thank you very much. So this project has been guided by collaboration between tribal government, Chickaloon Village Traditional Council, and Adelphi University, where we really center and elevate a Dene lens for archaeology. And that includes selecting where we do fieldwork, when we do fieldwork, recognizing important places, and interpreting finds. And that also means that funding has largely been initiated and controlled by CVTC for the project. So that's really decentering where the control comes. It's normally coming from the academic institution. So we'd also like to thank the National Park Service, Tribal Heritage, and do you want to hop in there, Angie?
Yeah, and Administration for Native Americans, they are actually a big supporter of the work that we do, and there are 3-year grants, which is nice reporting wise and turnover wise. So that's been extremely helpful. And for anybody here that's working for and with a tribe, I would be happy to share our work plans and our narratives and anything that helps get you started if you're not familiar with that funding source. I also want to apologize, as we do before we go out and do any field archaeology. I don't want to be offensive, or if I say anything wrong, please forgive me. Before we do any site work in any places, we're not sure if there are conflicts or bad things in those areas, so we have to make apologies before we start going into the ground.
All right, next slide, please. And just to start here, so you're looking at a map of Alaska, and we've been really focusing on the Matanuska watershed, and in particular on the northern side there. And just to reiterate that, you know, in the program, the authors are in a certain order, but we're really contributing equally to all of this work and to the presentation itself. So according to oral history, for many generations, the Matanuska watershed has been an important migratory corridor and ancestral territory for Chicxulub Native Village, federally recognized Ahtna tribe in South Central Alaska. We've heard at the conference this year many presentations noting how climate change is impacting people, cultures, and archaeological sites around the state. And we see that in the Matanuska watershed as well, but there's a parallel pressure that's also happening simultaneously, and that's land privatization, which makes sites accessible or inaccessible to CVTC, who is really interested in reconnecting with places that they haven't had access to. So we select places to learn about in part because of these pressures, the land privatization development, as well as climate change, and to connect to that information that was lost from settler colonialism. And so today we're going to give you a 2021 update of fieldwork that, and you're really going to see how we're integrating oral history with archaeological fieldwork. You'll see lots of narratives coming out from interviewing and consulting culture bearers on their experience and memory on traditional lands in the Matanuska watershed. And we're also guided by these questions. How widely were the mountainous regions around the watershed used by Dene, and how do we see that reflected in the archaeological record? And particularly, we've been working on the trail systems. And so we're also simultaneously asking how closely is oral history matching what we're seeing on the ground. And so our overall goals are to develop this synthetic watershed perspective for Dene, and what you're seeing is part of that process.
So as we're talking about this, I think it's important to point out that my elders have told me that when we tell stories, they need to be told in a certain way. So if you can wrap your mind around like this necklace I'm wearing, right? When we tell stories in the ways of archaeology and research papers, it's like ripping this necklace off and throwing the beads out. And we're just picking up one bead over here and one bead over here. So being fully recognizing of that this is not a concentric storytelling of place, but knowing that those place tellings exist, and they are very, there's a certain protocol in ways that we're supposed to be talking about this. And so this is not that. But I want to point out Caribou Creek and Chicxulub River and just those high mountain passes that we have been kind of looking at and investigating. The interesting things about them is they kind of wagon wheel, if you will, into all of these other drainages. And we wouldn't have known that without getting out there and kind of really experiencing it. You don't really understand that all these trails just drop off into other really important drainages and trail systems, like Mazuma Creek comes off of one of these. And one of the interesting things about Mazuma Creek is it's Yiddish for cash or money. And so to us, is that a place where the gold was? Because we certainly knew where that was. Or was that a trade trail? And trade trails have a whole different protocol. Only certain people were able to use them. And they were quite frequently high mountain trails. And that's something we know about this, is that this trail, the trail that went through the area that we spent it time in last year was called Summit Trail.
So we'll try to keep you on time and run through some slides here so that you can really hear some of these narratives. But you're looking at a map of previous work. So the blue smaller dots were sites that were reported in the AHRS before we started doing this work together. And the yellow triangles and red lines, those are places that we've started to focus more intensely on recording cultural sites. And you notice that, you know, there are a lot of unrecorded sites out here still. It's most of the work has really been focused in the road corridor, and even there we're finding a lot of material that wasn't previously reported, and much is known in oral history, but I personally don't have a comprehensive knowledge of that oral history. So let's look at some more slides. Yeah, so while we were landscape learning, you're looking at a map here with Boulder Creek and Glass Creek. This is an area that we had been reported to us in many interviews, and we should visit this because of detailed knowledge about how to get there, what was there. But really, it also highlighted to us the importance of Atna travel narratives. That's something that Jim Carey has done a lot of work around. And these travel narratives, they remain integral to the conversation for CVTC and other culture bearers that we've talked to, like knowing what side of creeks to cross and where, intersections of trails. And there's a lot of topographic relief here, and lots of preserved vegetation. So plenty of potential for archaeological sites. Next slide, please.
All right, is this me?
That's you.
All right. So one of the things that I have to point out, as Indigenous people, I think we are fanciers of rocks in a different way. I've legitimately been walking from office to office, and my uncle, who's no longer with us, called me over. He was working heavy equipment. He said, "Hey, get that rock for me. We're in a gravel pit." I'm like, "What?" And he was able to like tell me which rock, and he wanted to see it closer because we're just rock hounds. And I think there's really kind of some indigeneity of that. We're always looking for special and different rocks. And I think that's because we use rocks in so many different ways before, and really understanding this landscape in particular in the area that we went to makes me know that this was kind of a traditional mine area, if you will. It was a very productive landscape for the different core materials that people used. Go ahead, Katie.
Great. Yeah, so you're seeing some of that raw material here and just enthusiasm for the geology of the area. And the other thing you're seeing in this particular image is that in some of these places, particularly down on Caribou Creek, you lose a lot of visibility. And that's something that was reported to us over and over again for the area. Next slide.
Yeah, that it's kind of creepy. And there were actual places that we had to follow the trail that I would actually sing us in one of our traditional respect songs, because I didn't want to bump into the big hairy things with claws. This is one of the rocks on the right-hand side. This is obviously copper, and our word for copper, funnily, is rock excrement. So I just wanted to share that, but we certainly knew rocks pretty gosh darn well.
Next slide, I think. Am I looking at this correctly, that we've got about 6 minutes left?
Yeah, I think so.
Okay.
Yes, but you can have another extra one because we started a little late on yours.
Great, thanks. You can keep us in line. Thanks, Hollis. So one of the reasons we came out here is because we've heard from a lot of folks, archaeologists, from culture bearers, from rock hounds, that there's obsidian here, and had some conversations with Jeff Rasick about that. So we came to sort of ground truth that and actually put a physical GPS waypoint on that. So you're looking at, this is Glass Creek here, and you can see the obsidian deposits here. It's pretty dynamic landform. There's rocks falling all the time, maybe because of a fairly sizable earthquake last summer, but there's obsidian everywhere. Next slide. It initially was described to us as having these inclusions in them, and we definitely see that. Some of the obsidian's really crumbly, doesn't hold up very well, but if you keep looking around, there's definitely obsidian that you can flint knap. And so now the Museum of the North has that chemical signature, and we can start to get a sense of how regionally or wider this material is being shared. We've seen obsidian in other local sites and anticipate it might be coming from this source. Next slide.
So this is the mythical waterfall that I've heard about my whole life, but never been able to go to, because literally it is quite a cornerstone in our family conversations about places that my father and uncles and aunts and everybody in our family have always tried to get to, is Glass Creek. And so this is a really important place for us in a lot of different ways. One of the reasons is the picture on the right-hand side, those high mountain areas, the medicine and the plants are different, which is kind of an aside, but there's just so many aspects of these high mountain areas that are important to our culture, and I just wanted to point that out. Again, I'll just talk about the fact that this is a summit trail, and it could possibly be used for trading. You'll see Glass Creek in that high left-hand side in the yellow rectangle. That's where it is. It's in the upper reaches of Caribou Creek, which we know was used a lot by our people in trade and travel.
Yeah, so that's a place name that we didn't know going into the field work, but after we came back and described the experience, culture bearers that was eliciting new memories. And so having those continued conversations was really important. And we can just kind of flip through slides pretty quickly just to show you that we are finding artifacts kind of all over the landscape, particularly when you get into the higher elevations off the creek. So these are mostly at around 4,000 to 4,400 feet. ASL, lots of different raw materials, and some which archaeologists might not consider nappable, but still are pretty beautiful and would have had importance or value beyond necessarily flint napping, especially this green banded rock.
We were flying in and out on plane, and my auntie is a rock hound, and I was like, we got to fly back out. So she just had to practice a lot of restraint. That rock on the right side may not have any practical use, but it is a fan favorite. Everybody I've shown photos to just loved it. Yeah, here's us out there doing the field work.
Yeah, so these are images of another trail connecting in, and Fran, I'm not sure if you want to talk about the site.
We have 2 minutes, maybe 3.
Take me 2 minutes to get on. Yes, this was a site that was across from our campground. We traveled up the mountain and took some of the trails that had been bit into the mountain by four-wheelers, and we did find some debitage in those trails. But it was very interesting that as we went up, we noticed that there were a number of benches, sort of almost like platforms. As we went up the mountain, there were some to the left, some to the right, and we stopped at the first platform, and we noticed that some marmots had brought up some debitage onto the in the shrub, and so we decided to put in a 50 by 50 centimeter shovel test right where the marmot had brought up a piece of debitage. Lo and behold, within that 50 by 50, we found handfuls and handfuls of debitage. And looking at the landscape, it was easy to imagine early Dene people in that area looking down on the Caribou Creek Canyon and waiting for caribou or large ungulates to come through that they could hunt. And we anticipate the other platforms having additional debitage. We only checked that one, and there was I don't know, several hundred pieces. We left some behind because there was so much, but we did get a charcoal sample that was associated with those charcoal with the debitage, and we got a date of 3730 plus or minus 30 dp. So we're really excited. Also, when we were up there, it was like 90 degrees that day, and you can see we put in that little wiki up so that we could have a little shade for our lunch that you just saw in the previous picture. But it was really,
It was prohibitively hot. Yeah, just real quick at the end, the stewardship in this place was something that we exhibited, I guess, to Katie. We immediately started clearing all the debris, and that's just the way we do things. We were gonna really quickly touch on some other projects that we did, but I think we're pretty much out of time. This is 68.1. I'd love to talk to you guys about this. This is some field work that we did there, and it almost went sideways, but it didn't. Caribou Creek, Bonnie Lake with BLM. Boy, these slides take a long time. And Campbell Creek. So we were busy, and King River. So we were very busy this year, but I'll sign off because I know we're out of time.
Thank you so much. That was a great presentation. I love your storytelling. So I see we have a question from James Kari. This is the break, the 20-minute break. So I know there were also some people that had questions for Buster that they were holding. So this would be a great time for that.
One point. Okay. Yeah. Seeing that screen capture from our web map, I recognize some of those names were told to me by Johnny Shaganoff, and not like that now Kluge is definitely some kind of rock, you know, and it's a real rare word. It's a real word. I think it probably has something to do with glistening. But the lithic prospecting is a major theme in the Dene place names, especially when we have concepts like vanguard place names and founding place names. And I'll stop for now, but I'm the next speaker, and at least I can test that out. So thank you.
Yes, thank you.
Yeah. Sorry, thanks, Jim, and thanks for all the work that you've done. I feel like we owe a lot of this to you. You were listening when a lot of us weren't, so I really appreciate that.
Were there someone had a question for Buster? They mentioned in the chat they were going to hold it. This will be a great time for that.
Yeah, yeah, that's me. Yeah, Gunalchish, thanks very much, Buster. I'm really impressed with your work in Southeast Alaska there. And I'm curious if you have any comments on the possible presence of clam gardens or clam terraces, so deliberately constructed shellfish beds in Southeast Alaska. These are fairly common along the coast of British Columbia, but to my knowledge, there's only one or two identified in Southeast Alaska. And I wonder if you have any comment on that, or comment on the possible relationship between fish weirs and clam terraces or shellfish beds there in Southeast.
Yeah, that's an interesting question. I haven't specifically looked into clam gardens, but I do know they exist, and they were pretty widespread, like you said, through British Columbia. But that's something that definitely needs to be looked into more, because it's a resource that's so easily exploited that basically any of the our ancestors aren't going to leave anything on the table, as it were. So yeah, I definitely think that's something that needs to be looked into definitely something, somebody needs to do that.
Terrific. Thank you very much.
All right, so we'll take these next 15 minutes for our break, and then we'll return for James Kari's presentation. Thank you to all our presenters so far. Thank you myself.
All right, can someone, who's the moderator of the next session? Does anyone know who the moderator is of the next session?
I'm still finishing up the previous session.
I believe Hollis is still, is that accurate?
No, there's nobody. Yeah, I'd like to set up my screen share ahead of time.
So how do you like your time? I hate it. Other things different. You know, I did 3.5 years since I retired. The first year, on the day I retired June 30th, July 1st, my boiler blew up. So that $10,000. So that put the kibosh on my plans. And then I needed some minor foot surgery on, I think I was some of the last surgery done before they shut down for the pandemic. And then that's been kind of the thing, but yeah, now I'm used to it. I thought I was prepared for it. I was not prepared for the financial, the physical, and the pandemics. How long did it take you to get used to it? Didn't take any time. I still miss my job and my friends at work. I didn't intend to retire then. Oh, okay. It just was a good time in a way, one way or another.
Yeah, I didn't like someone they brought in who then left a month after me.
I was 60. I worked those
Started already?
canon on language.
Hi, who is the moderator of this session?
That's me, Hollis.
Okay. Yeah, thank you.
No, no problem.
How
Yes,
is my screen?
we'll get started right on.
How is my screen? Is it visible?
It is visible. So it looks like you've got a poster open. Is that correct?
I'm gonna navigate through the
Okay. Yeah, no, we can see
and
it.
zoom in on certain things. Mhm.
Yeah, the Zoom will definitely be important for us to be able to read or see things in detail. Yep, that looks great.
Mira. Mira just logged in. Hollis, can we start now? There's several people joining from Russia, and I want to mention that early. Okay, go ahead.
Yeah, you can go ahead. It's 1:20 or 12:20 in Alaska. Sorry. So yes, please go right ahead. James Kari, would you like me to read the title you submitted? The role
No,
of
that's fine.
Yeah. So yes, James Kari will be presenting the role of Dene, Geo-linguistic information in Alaska prehistory. Take it away.
Yeah, first of all, I want to recognize the late Bill Workman, who I met at the very first Alaska Anthro meeting in 1974, and he was the first president of the Alaska Anthropological Association. There's a couple of people joining us. Andrei Kibrik, who's the director of the Russian Institute of Linguistics in Moscow, who works with Nikolai and Upper Kuskokwim language for many years, and his wife is Mira Berkelson, and their assistant Marina Raskladina. They've been working with the Nilchik Russian dictionary and the Russian Creole Russian, and it's a real thrill that they could join us today. So the Dene languages reinforce one another, and the nexus of the information are these computerized dictionaries. So the outline of the Lower Tanana that I'm putting together is very much like that of the Otna dictionary. It has main entries, it has a word initial index and an English finder list. And Sharon Hargis is probably on this call. She's from University of Washington. She and I are both doing these Dene band label dictionaries that foster comparisons as well as the integration of vocabulary and grammar. So the verb complex I've been working with in Lower Tanana is the first one where I'm trying to establish a full inventory of the prefixes and the suffixes. And when we did the Koyukon dictionary or the Otna dictionary, the superscripting of the prefixes, and some of them are homophonous, was really ad hoc. So if you look at these zeros here, like 01 is the zero classifier, 02 is a zero subject, 03, zero mode. They go up as the prefixes go up. There's 6 zero prefixes, and then the zero suffix is 7. And I like to say, I mean, this is supposed to be a joke. If I can count zeros, then I can count everything else. I've been pushing this symbols for mutually exclusive and haplological. And haplological are prefixes that can occur multiple times in derivations, but only on the surface once. So this part here is an example of a split screen. It's where I can look at 2 dictionaries at once. For example, this is called folding the lines with a regular expression. And I can do this anytime and see the Lower Tanana as an outline with the top 4 lines in the headwords, or say the Denina, in this case on the left. And you can monitor, notice there's 19,000 lines for Lower Tanana, but 30,000 for Denina, because it's the largest dictionary in Alaska. And so we're looking at the G section, and then right here is this table of headwords. And there's something truly inspiring, frankly, about the table of headwords being that this cosmographic outline. It has principles of correct placement of both the grammar and the lexicon. And you see various interesting things like fish scales or snowshoe hare are their own roots. I have a term for that about nouns without verbs. And anyway, this folding the lines is my idea of a religious experience. So I have a similar flow chart in the Otna dictionary, but I've taken it a little further with the Lower Tanana. And some of these layers are recursive, like theme formation strings. I consider to be a major growth area in the Lower Tanana. Now let's move over here where we talk about this theory that and some of my claims about the time depth of the glacial Lake Otna. We got 2 choices. We could begin with hydronymic districts, or we could begin with the map, the last plate in my 2019 paper. This map is pretty visible at 50%. And so what a geolinguistic cognate is, and they are located names that you can tell are pairs, like this name in the Ketchumstock uplands, Nin, is the same as Nene, the Golkana-Susitna uplands. And there's a third one on the south side of the Alaska range, Tsinen. So those are ethnonyms and pioneering names that show some kind of a drift or order. All the names I selected in my 2019 article have been on record since the 70s and 80s with the same locations and translations. And it's sort of phenomenal to realize the implications that Sosnu Bennett is both the head of the Golkana and the Copper River, and it's the head of the Susitna River. They've duplicated those names to talk about the headwaters of these. So I've in the supplemental pages of the 2019 paper, I have in 3 categories: historical linguistic markup that I can use with place names. The Natale, or one question I say or ask here, and I've never lectured on this, by the way, so if I spend 5 minutes on it, that's all you're going to get. I haven't presented this in a lecture format, but this Tate Nig for Beaver Creek in the Canadian side, and then for Stuver Creek here that comes in around Northway is the same. It means water rock or stream cobble, and this is creating sort of like a state highway system that tells you you can go up Beaver Creek or up Stuver Creek for stream cobbles, and that of course is where the Wiki Peak source is. The place names are overtly informative and analyzable. Even just the mere fact that no other glacial lake in the world has as many place names recorded in its basin. We could talk about 2,000 or however you want to talk about the the Matanuska Valley. Even what's really interesting is that Caribou Creek that they mentioned in the previous paper is Natale-Lena, and that has water and the verb to flow down. But then the name for Devil Canyon and Baird Canyon are both Natale-Aden, and that's what the only thing I can explain about it is Len is the common verb of current flow that appears in Navajo and other languages, and the Atna or the ancient Dene had a term for torrential current flow, and it's a remarkable fact that Baird Canyon and Devil Canyon are a duplicate. And say this name, what is the time frame of this duplication of the name? Let's say Baird Canyon wasn't even accessible until 1,000 or 2,000 years ago, but this was accessible in 12 or 13,000 years ago, or 12,000, and things like that. Anyway, Net, yes, is this ridge that is at the divide, and that means world or land ridge. Well, there's no other place in Alaska in 12,500 Dene place names that's called land ridge. And Net, yes, a guy is little land ridge, this esker that flows from, that extends from Sourdough down to the this bend on the Catalina River. So the theory that I put together on this, I refer to as the proto-Dene lex loci, and I'm not sure, I discussed this with students and colleagues, but I haven't presented it. But this concept of hydronymic districts, I wrote about it in 1996 in a couple of articles. And Bill Bright, who used to be the late Bill Bright, who used to be the editor of Language, actually suggested we copyright that name, and he went and copyrighted hydronymic districts in 1996. But this is this kernel density map that Jared did in his dissertation, and he's modified since. And the white lines indicate ethnonym territories or band territories, and they might straddle drainages, but we have pretty good records of all the Dene band territories and ethnonyms. But the Dene network extends beyond the red lines of the historic contemporary language boundaries like on the map, but their name networks extend far beyond the map. And we'd have to say that the Kobuk drainage was all Athabascan and going out to the coast. The Unalakleet River, actually very clearly, even as late as 1880, Koyukon would have had the Unalakleet River. And in general, this corresponds with Ben Potter's extended northern archaic distribution too. And these names are rule driven and analyzable etymologically, so that they become this is an auto-instructional geography. So when you think in particular about something like why High Power Creek at the corner of the Alaska Range has a reverse hydronym. So a reverse hydronym is using avenues like streets to highlight in a street system. And there aren't that many of them. I think I have less than 40 reverse hydronyms in Alaska. And why would they name High Power Creek as the first most upstream drainage of the Kuskokwim River? Tatashnik would be the proto-Dene, and that means black stone or possibly coal or something. And then Teosnik in the middle. I mean, why does the pipeline go through Adigan Pass, right? Well, these people knew that that was the main corridor to the North Slope, and that's whetstone, Teosnik. That is the only reverse hydronym in the Brooks Range. So the brilliance of that, like I write about these, I say here, these watershed tenure devices reflect profound trail reconnaissance and lithic prospecting in two founding place names. Of course, the snowshoe had to be invented. There's lots of things that time perspective hypotheses you can do with geolinguistic data. And they also can, there's no reason that you would expect these names to precede the archaeology. Other generalizations I make here that I do feel in Rich Vanderhoek's paper that's and Jangla and the entire group on Glacial Lake Otna, I've had versions of his slides, but that reinforces the argument I'm making in the absence of knowing much about the 11th millennium. But Vanderhoek's group, and it's very cool. He names the two first decantings. He calls the Little Lake Louise decanting, in this one that's on the north side of the Tyone River that's called Tanahina. So there's no question that the names that I call an ensemble of names were kind of a teamwork among maybe even 5 or 6 guys as they did those founding place names. Let's see. Are there any comments? If I'm going to pause here for comments. So this word formation theory talks about it
looks like you do have a comment.
A simplex complex dichotomy. Yeah, I can't. Yeah, Andre, yes, please.
Hi, Jim. I read your poster before and I have
Hi,
a
Andre.
question. Do you suggest that the Alaskan Dene were moving originally east to west, somehow from Canada to Alaska? That's what you're suggesting?
Yeah, well, I'm saying the earliest archaeology that that Ben Potter is able to trace it, yes, would go further east, but we still have to allow for pretty early entry into eastern Alaska, 12,000 years.
Mm-hmm.
It's so good
And
to
could
see
you
Andre.
clarify reverse hydronyms? I didn't quite get what that term means. Reverse hydronyms.
Well, in the hydronymic districts here, in Nika is like the Gwich'in word jik for stream is the dominant upstream hydronym in eastern Alaska, and it's in upper Tenotan across Hanagwich'in. But Na is the dominant hydronym. I think Na is based on that motion and moving, or it's also a word for omen. And Nika is clearly, literally upstream, on the upstream. And the hydronymic districts extend throughout Canada. There's 7 of them, and they appear to be stable for a long time. I don't know if you read Ed Vita's 2019 paper, but he discusses hydronymic districts. It's wonderful to see you, Andre.
Thank you.
Of course, there's a lot of people to thank, and I could thank. I'll just say this land acknowledgement. Duke Drana, and Nick Hoggett, as Kathryn. Today, we are working and living on the band territory of the Chena Band. I also think land acknowledgements can be language learning opportunities. People can practice them. If you have a frame or a phrase that can be substituted and standardized, it's good language learning opportunity. So as my friend, the late Shem Pete, used to say, "Ko shijan, ko hachkash nashti, ko duta rashchus." There, I've said enough now. I'm going to shut up.
All right. Thank you for a great presentation, Dr. Kari. We have time for one question if someone else has one. All right, and there will be time at the next break also for questions for the set of presenters. So I'm gonna have us move along to get Abigail Judkins' presentation set up. Perfect. So Abigail will be presenting next with a paper entitled Market Integration and Human Environment Interactions in Northern Alaska, Data from the Walakpa Site. And it's now 40 after, so feel free to take it away when you're ready, Abigail.
Okay. Hello, everyone. So my name is Abby Judkins, and I'm a grad student at the University of New Mexico. And today I'm going to be discussing some preliminary research for my dissertation work titled Market Integration and Human Environment Interactions in Northern Alaska, Data from the Walakpa Site. So over the last 50 years, the warming climate has caused significant damage to the environment across the globe. We've all noticed the changes in weather patterns and increased natural disasters, from tropical storms and hurricanes to the wildfires in the Western United States, but especially at risk are coastal environments. And additionally, over the last 30 years, the Arctic has warmed at approximately twice the rate of the rest of the globe. This has led to decreasing sea ice cover, less snow cover on land, retreating glaciers, melting permafrost, and coastal erosion. The effects of climate change have contributed to changes in animal populations and behaviors, loss of livable land, and a loss of archaeological materials as their provenience is disturbed or washed into the sea. This degradation of the environment is unfortunate and has led to mitigation projects focused on saving portions of the archaeological sites most at risk. These projects, at least in Northern Alaska, have focused mostly on the prehistoric record and the peopling of the Americas, but the historic record from the region is equally at risk and has the potential to address some important questions about this time period. So the historic period in the Arctic is characterized by a variation in interactions. Initially, it was episodic and sporadic, with Europeans coming to hunt, and then increasingly longer interactions as people began overwintering in the Arctic and establishing trade locations. This situation presents the opportunity to look at how colonization processes varied through time as new people came to the region and introduced new social and economic pressures. Within these different colonization processes, we can look at how the introduction of large-scale commercial trading altered the ways that humans are interacting with their environment and the role that commercial trading played in the intensity of interaction. The increased presence of people and the associated changes in the economic and social situations would have altered the human-animal landscape interactions in this region. So one of the Arctic regions that was affected by commercial trading was Northern Alaska. Here, the historic period starts in 1750 with the emergence of the fur trade in Southern Alaska. While these activities were focused on the southern portion of the state, it's known based on ethnographic accounts that traders made expeditions north to the area that includes what is commonly known as Burrow. Here, they engaged in trading with local communities where fur items, including caribou and fox skins, and hunting tools were exchanged for items like copper kettles, guns, and tobacco. During the fur trade period, there were no permanent colonial establishments set up in this region, and interactions that did occur were sporadic or happened at designated rendezvous points. However, starting in 1847, the whaling industry began to hunt bowhead whales in this region. This animal had been a primary economic resource for groups in this region, and the extended presence of whalers led to more trading. And eventually, trading posts were established in Northern Alaska. Coastal satellite villages were abandoned in favor of larger whaling villages. Local community members were hired to work on these ships, providing reliable access to Western goods. Though these interactions were not without issue, increased interactions led to social problems, depleted animal populations, diseases being introduced to the region, and disrupted social life. So given all of that, my dissertation is going to be looking at how the increasing level of market integration and participation affected human-animal landscape interactions in Northern Alaska. My data is compared between the late Thule and the historic period to assess how the introduction of commercial trading affected the ways that people were interacting with animals on the landscape. Answering this question can be difficult since in Alaska, a lot of the Arctic excavation projects have tended not to retain the faunal materials, and even less frequently, they retained historic material. And this makes this project one of the few opportunities to address this type of question for Northern Alaska. So the site of Walakpa is located along the Northern Alaska coastline, approximately 13 miles from the town of Ukavakik. It was originally excavated in the 1960s as a part of Dr. Stanford's dissertation project assessing the transition from Birkenau to Thule cultures in this region. The site has an extensive occupation with materials dating back to the Arctic small tool tradition, and it was still being used by local communities at its time of excavation in 1968. During his excavation, Stanford retained some of the historic material and collected faunal materials. Based on my knowledge of the historic material, this component does date back post 1750, but one of the things that I'm working on is analysis of the rest of the historic material to establish a chronology within the historic occupation. Walakpa affords me the opportunity to look at how human-animal landscape interactions shifted between the late Thule and historic period, since both faunal and historic materials were collected. So I'm going to talk about my preliminary results. So to do this, to look at these questions, I looked at changes in representations of identifiable mammals between the periods to see if there's a shift in the pressure placed on specific species. I should note that these species represent the animals that have been identified in my analysis to date, but it is possible that as more analysis is conducted, I will add more data to this table. Additionally, some categories have been collapsed due to identifiability issues. Dog and wolf have been combined due to the likely hybridity between these species and the challenges in distinguishing between their postcranial elements. Additionally, foxes are collapsed since Arctic foxes and red fox are both present, and distinguishing between them can be difficult. I also collapsed seal species with the exception of bearded seals, given that they are much larger than the other species present in northern Alaska. Finally, all whale materials were only identified to the cetacea species, given that a lot of the materials degraded and unable to be identified to species and due to a lack of comparative material at UNM. So to assess if there was a shift in the way that animals are being used between the periods, I've looked at the element distribution for both caribou and seal. I chose these animals since they are known to have been important food resources, but were also used for their secondary products and were likely to experience a change if the increased commercial trading was placing more pressures on animals on the landscape. Additionally, they were the most numerous animals in my sample of materials, suggesting that their importance to the people at Walakpa. It is known that caribou and seals were skinned before the historic period to make clothes and other objects, and were traded with other groups for access to goods that were not otherwise available to them. If there was an increased demand for one or both animals with the large-scale commercial trading, it would be shown in the elements that are often left behind in the skinning process. Values were compared statistically in the form of chi-square and Spearman's correlation in the statistical software PAST. The result of the species distribution suggests that there is a statistically significant difference between the distribution of animals between the late Thule and historic period. The effect size for the chi-square test was relatively small, so I decided to also run a Spearman's rank order correlation test, which showed that these distributions are correlated. This result is not surprising given the limited number of animal species on the landscape and the dominance of caribou in both periods. Some patterns that were of interest with this is the relatively large increase in the number of dogs and fox during the historic period. Dogs jumped from 12 in the late Thule to 48 in the historic, and foxes jumped from 6 to 41. This pattern is of interest given that the fox were another animal that was targeted during the fur trade, and dogs were important transportation animals. Additionally, there's a substantial drop in the number of caribou that were identified during the historic period, but the number of seals remains relatively stable between the periods. In looking at the seal element distribution between the Thule and historic component, it is seen that based on my chi-square test, they are significantly different from each other. However, my effect size is relatively small, so I again ran a Spearman's correlation, which showed that the distribution is strongly correlated, suggesting that there's a strong relationship between the distribution of elements between these periods. This test also suggests to me that there's a consistency between the way that seals are being used during the late Thule and historic period at Walakpa. Since skinning was a big part of the economic development during the historic period, I looked at specific evidence that suggests this behavior was occurring at Walakpa. The results from my distribution analysis showed that seals were being exploited in the same way that they had been used in the Thule period. In doing my analysis, I noticed that there are a large number of seal foot bones in the skinning process. It has been documented that foot bones are often what gets left behind. So to see how extensive this pattern was, I plotted the number of each type of bone for the species against how many are present in a single skeleton. The red dashed line is the presence at Walakpa, and you can see that for tarsals, metatarsals, and phalanx, this holds true. This pattern is true for most of the seal elements from Walakpa, but you will notice that metatarsals are the second highest presence after ribs, and that tarsals and pes phalanx are also high. This suggests the likelihood to me that these animals were being skinned in the historic period. However, the results from my caribou element distribution were slightly different than for the seals. The chi-square results suggest that the element distribution is significantly different between the Thule and historic period, with a stronger effect size, but the Spearman's rank order correlation only suggested a moderate correlation between the distributions. This suggests that there may be a difference between the Thule and historic period caribou element distribution. Caribou were target for pelt and as a food resource. So this pattern may be the result of these animals being used more extensively, leading to a greater diversity in element present in the collection during the historic period. For the caribou element distribution, you can see that there's not the same clear pattern that we see with the seals, though there is a large number of metapodial elements present in the historic material. This may have resulted from marrow processing, or it has been discussed elsewhere that metapodials were used to make hide scrapers, and if this was a more intensive skinning happening, there would be an increased demand for hide processing tools. More work is needed to assess if the increased number of metapodial elements is related to intensification of these animals as a food resource or due to their demand as, for secondary products. Right now, the conclusions of my analysis suggest that there's a shift in the human-animal landscape interactions between the late Thule and historic period, but it seems to be focused on specific species. The species distribution showed that there was a drop in the presence of caribou during the historic period and an increase in the number of dogs and fox, but the presence of seals between the periods remained relatively stable. Additionally, while my chi-square test suggests a difference in the seal element distribution, the effect size was my effect size was small, and Spearman's rank order correlation suggests a relatively strong relationship between these periods. This suggests that there is stability in the use of seals between the late Thule and historic period. However, looking at the caribou element distribution, the chi-square suggests a difference with a stronger effect size and a lower correlation. This leads me to think that there's a shift in the way people were using caribou during the historic period. However, I think it's important to note that I need to consider the effects of natural cycling of caribou and fox populations in this region, which I will be working on in the near future and may influence the interpretations of my results. Finally, it looks as though there was an increased reliance of dogs and fox during the historic period, but more analysis is needed before any conclusions can be made about that. I don't yet have enough data to answer all of these questions, but once I do, I'll be able to look at if the increase in foxes is related to them being targeted for pelts, and whether the increased pressure on caribou in the historic period was forcing people to travel further to access these animals and led to an increased need for dogs to help in transportation. In moving forward on this project, I will be finishing my analysis of the late Thule and historic fauna, including analysis of butchery patterns in human and non-human modifications. Additionally, I will be looking at demographic and fragmentation of animals in the historic period to look for evidence of intensification during the historic period, and to consider whether the increased pressure on animal populations led to changes in how intensively these animals are being used. Finally, I will be analyzing the historic material to distinguish between the fur trade period and the time of the whaling industry to look at how, if possible, the sporadic versus sustained interactions affected these patterns. Especially important is that this data only represents what we know about the Walakpa collection. There are many regions within the Arctic where this pattern may have varied, and it would be interesting to see what effect the introduction of commercial trading had on other regions in the Arctic. And one of the big goals of this project is to create an online museum exhibit where the information about the fauna from the site, but also the information that the Inupiaq community is interested in having shared will be accessible online through the Maxwell Museum here at UNM. I would like to take a moment to thank Dr. Emily Jones for her guidance and assistance with this project and for providing me with lab space in the zooarchaeology lab at UNM. I'd also like to thank all of the members of my committee as I continue to develop this project. And finally, I would like to thank the Idaho Virtual Museum, Museum of Southwest Biology, and the Museum of Vertebrate Zoology for their help in identifying specimens.
Thank you, Abby. We have time for a couple questions. If anyone has questions, I noticed that Liz Ortiz left a note for you in the chat, Abigail. I'll read it out loud if that's all right. Traditionally, people save and ferment the seal flippers to eat later. There might be some cultural reason that there is a higher number of foetid metapodials rather than what you expect based on bone count per skeleton and distribution.
Okay.
And Liz also says, please say hi to Emily Jones for me, who got me into Zooarch.
I will.
Other questions for Abigail or for Dr. Kari, whose presentation was before this? Great. Well, we will wait until the top of the hour to start the next presentation so that we stay on the schedule in case folks are joining for specific talks. But I'll go ahead and announce our next speaker, who will be Miranda LaZar, with a talk entitled Human-Bird Interactions at Palangana, Analysis of Lagopus Remains from a Nunamiut Residential Site in Alaska. So if you want to start getting your slides up, Miranda, you can do that, and then you can begin your presentation at 1.
Thank you, Hollis.
You're welcome. And good to hear your voice and see you for the first time. Although I hear you're coming to Seattle soon.
Yes.
There's some fine looking birds.
They are.
I know, and the reason that I haven't done any bird ID on the remains here is because the Burke tells me that you and Nicole Misarti have all the samples for the relevant species.
Oh.
No shade intended. It's just the reality of working with museums. Sometimes not everything's available at once.
Yep, that's true. I'll try to finish quickly.
Thank you.
You're also always welcome to visit Hollis.
Thank you. I will see if I can squeeze a trip in this spring. Let's give it another minute here. All right, go ahead, Miranda.
Great, thank you so much for that introduction and for helping kind of organize this session. I also want to thank all the other conference organizers and to everyone else who has presented before me. I've really enjoyed listening to all of your presentations. So my name is Miranda LaZar, and I'm a PhD student down at the University of Arizona. And as Hollis said, I'm going to be talking today about human-bird interactions at Palangana, analysis of Lagopus remains from a Nunamiut residential site in Alaska. So the Nunamiut are a group of semi-nomadic inland Inupiat who live in Antiquity Pass up in the Brooks Range in kind of northern Alaska. And they are caribou specialists, but will supplement their diet with Dall sheep and ptarmigan. And most notably in archaeology, Louis Binford had went and lived with the Nunamiut for his Nunamiut ethnoarchaeology project, where he lived with them from 1969 to about 1972. And during this time, he excavated the Palangana site, which is a proto-historic Nunamiut winter residential settlement that is located on the shores of Tulagak Lake, which is just north of the modern village in Antiquity Pass. And the site was occupied during the late 19th century for 2 consecutive winters. And it's comprised of 4 winter houses, of which 2 were excavated, the Palangana household, as well as the Kapkana household, and the surrounding yard, including yards where dogs would have been kept. And most of the previous research that has come out of Binford's collection from the study has focused a lot on the large game, specifically the caribou, looking at meat utility indexes, as well as butchering patterns and sharing of meat between the 2 households. And so I became really interested in this because nobody had looked at the avifaunal remains from the site. And as ethnographic evidence and other accounts from this time period show, ptarmigans were super critical to Nunamiut lifeways as well. First through subsistence, as it's stated here by Gerbser, many Nunamiut speak of the ptarmigans as an invaluable dietary supplement, especially in hard times, which are not unusual in the Brooks Range. Had there been no ptarmigan, some people would have had to starve to death. And I think this is important too, because a lot of people, when thinking about the Nunamiut, really think about caribou subsistence. And so it's important to also recognize kind of these other species that really did have an impact, sometimes between life and death in these kind of harsh winter environments. Not only were they used, they were primarily used for subsistence, there are accounts of them occasionally being hunted to use the sinew on the sternum to help sew parkas as well. And ptarmigan were hunted by everyone of most ages, including the children, as Ingstead writes that the children are active in hunting and catching ptarmigan. The girls set snares along offensive boughs erected in the snow, just as in Norway. The boys stalk the game with bows and arrows and are great hunters. In terms of actually hunting the ptarmigans, they would use these long nets that would get stretched out in the snow, as depicted in this drawing that was drawn by Simon Paniak. And I just want to take a moment while bringing that up to recognize Simon Paniak and all of the contributions that he had to a lot of the research in Antiquity Pass and with the Nunamiut during the mid-20th century. And Simon was a Nunamiut individual who had a wealth of both traditional and local knowledge, and most of this work would not have been possible without kind of his achievements in that as well. And he worked with Binford on kind of helping to get interpretations of the Palangana site. In addition to the long nets, people would hunt ptarmigans using blunt bird arrows, and these were often made out of wood or bone, and they would be used to kill the birds with blunt force rather than through puncturing the animal. And then additionally, smaller snares were used as well. So there's 2 species of ptarmigan that are found in the Palangana assemblage. The first is rock ptarmigan and the second is willow ptarmigan. Both migrate in late fall and early winter, as well as late spring in Antiquity Pass, and they have different habitat preferences throughout the interior of Alaska. So generally, your rock ptarmigan are going to be found at the highest elevations, particularly on these upper hill slopes here. And willow ptarmigan are going to be found more on the edge of the rocky hill slopes and the tree line, as well as further down into the forested environments. And when they migrate, both species will migrate down in elevation, with the rock ptarmigan moving kind of into some more of the edge of this forested environment or open kind of shrub patches within the forest, where willow ptarmigan will move further down all the way into kind of willow riparian ecosystems in which the Palangana site sits near one. Additionally from that, females will migrate further down than the males will, so you do get some overlap of female rock ptarmigan and male willow ptarmigan in wintering months, which it's important when thinking about where they're located on the landscape and how far people would have to go to run into ptarmigans. But despite these differences and questions that it could help us answer in the archaeological record, they're very hard to distinguish morphologically, even by seasoned experts, which leads me to my research objectives of first, how did the Nunamiut obtain, transport, and process ptarmigans for consumption at Palangana? And two, can the ptarmigans be identified to species level using osteometrics to help us kind of get an idea about how people were using the landscape and where they might have run into ptarmigan species? So to do this, I analyzed the collection of ptarmigan from Palangana, which had a total of 962 specimens. With this, I looked at the skeletal part representation using a suite of zooarchaeological quantitative units. Additionally, I also looked at all of the cut marks present, particularly noting for disarticulation and filleting marks through observing the orientation and location of where the cut marks were placed on the bone. Additionally, I made note of any other taphonomic processes such as root etching, burning, carnivore gnawing, etc., that could have impacted their deposition in the archaeological record. And then for the osteometric study, I traveled up to the Museum of the North and measured a comparative collection of modern rock ptarmigan and willow ptarmigan. So I measured 56 individual rock ptarmigan for a total of 442 elements measured, as well as 11 willow ptarmigan for 87 elements measured. And then additionally, I measured 782 of the specimens from the Palangana assemblage. So starting off first, just by looking at the number of individual specimens present, we can see here that the femur and the humerus were the most abundant. There was 164 femurs as well as 151 humeri. And then this was followed by kind of the distal wing bones, so the radius, the ulna, and the carpometacarpus, as well as the tibiotarsus. The tarsometatarsus was significantly underrepresented relative to the other limb bones, as well as the shoulder girdle, so the scapula, the coracoid, and the furcula. The axial skeleton was almost entirely absent or very, very rare. And what's interesting to note here is that most of the long bones are complete in the assemblage, with the exception of the tibiotarsus, which is dominated by distal fragments. And the same kind of skeletal part representation holds through when we're looking at the minimum anatomical unit, which you can, with the only exception is that the humerus becomes more abundant than the femur. And you can see in this pattern here that the wing bone really is more strongly represented than the leg, lower limbs, especially these distal bones here. Again, you can see the same kind of pattern where the shoulder girdle is pretty underrepresented and the axial skeleton is almost rare or entirely absent. So when looking at the distribution of where the bones were recovered at the site, we see that about 86% of the bones were from the right outside the Kapkana household, whereas only 6% were found right outside the door of the Palangana household, and 3% were right near where the dog tethers were located. And this fits with the narrative of the Palangana site that was proposed by Nicole Misarti in her 2002 publication, which looked at modeling caribou sharing between the two households. And she had concluded that it fits a tolerated theft model in which the Kapkana household would have been receiving shares of meat from the Palangana household. And And this supports what we're seeing here, because if the Kapkana household did have more limited stores of caribou meat, then they would have been relying on more ptarmigan to supplement that diet to get through the wintering months. All right, so moving on to the cut marks here. Cut marks were present on 9 types of elements, but most notably the humerus, and then following that, the femur and the coracoid. And I just want to make a reminder that to note that cut marks themselves are not necessarily an accurate measure of how intensely the animals were being butchered, because the goal really is to not actually hit the bone when butchering it. But the marks that are left there can present some insight into the processes that were happening while butchering. So here, looking at the humerus, 114 out of the 151 humeri had cut marks present on the bones. And on these cumulative drawings, I have marked in black are cut marks that were just an isolated mark on the bone. And in red are marks that represent these patches of cut mark striations where it was impossible to get an accurate number of how many cut marks were actually present there. And what we see on the humerus is that both axial and diagonal cut marks are evenly represented, but very few are like truly perpendicular. There's one right here. And what this ultimately shows is there is evidence that could be considered as disarticulation, as there's a large presence of cut marks on the proximal epiphysis, and which would suggest that the wing is being disarticulated from the shoulder and main trunk of the body. However, and that can be, you can see some of those marks there. However, there's no, or rarely no cut marks on the distal epiphyses here, as well as there's no perforations of the distal humerus, which would be expected if people were manually disarticulating the ulna from the humerus. The ulna electron process of the ulna could have punctured the distal humerus, but that is not seen on this. And also, given the lack of cut marks, we can suggest that those elements were not disarticulated from one another. Additionally, there's also plenty of evidence of filleting marked by these longer kind of axial marks, as well as some diagonal marks on the proximal and distal shaft of the bone. Moving on to the femur has notably less cut marks on it than the humerus did. Only 29 out of the 164 femurs had cut marks present, and they were primarily on the proximal and distal epiphyses here, with just a few instances of it being on the diaphysis. And so this again suggests that more disarticulation, perhaps from the main kind of body, as well as potential disarticulation at the knee joint with the tibiotarsus, which may explain why so much of the proximal tibiotarsus are missing in the assemblage if they had been breaking at that location. And then moving on to the coracoid, only 16 coracoids had cut marks, and the majority of them were located along the head of the coracoid, further supporting that there was a disarticulation of the wing. All right, so moving on to the osteometric study, what we found looking at the comparative collection was that only the femur, the tibiotarsus, and the tarsometatarsus were statistically significant. And within that, the best measurement to use was the greatest length. Occasionally, the breadth of the shaft or breadth of the proximal or distal ends also were statistically significant, but they had more overlap between the two species and so were not as reliable. So what I have depicted here in these graphs, these brackets are 2 standard deviations around the mean of the modern comparatives. So this here is the willow ptarmigan modern comparative size range, and this is the rock ptarmigan modern comparative size range. And these bars represent the measurements taken on the archaeological specimens. And what we see is at Palangana, there's kind of, with the femur, greatest length of the femur, there's 2 kind of size groupings here. This larger one does fall within the willow ptarmigan size range, as well as some overlap with larger rock ptarmigans. In addition, and then the smaller one falls primarily only in the rock ptarmigan size range and extends even further small in size than what we see with the modern rock ptarmigan. And we see many more individuals represented in the smaller group than the larger. A similar pattern holds when we're looking at the greatest length of the tibiotarsus. Here, again, you get a couple of specimens that fall within the willow ptarmigan or large rock ptarmigan range, and then a bunch that fall kind of in this more range of the smaller rock ptarmigan. And then the best bet when it comes to looking at the osteometrics and the greatest separation is the tarsometatarsus. And here we can see a clear grouping of willow ptarmigan and a clear grouping of rock ptarmigan. Again, we get some individuals that are smaller than the modern rock ptarmigan, and there's more rock ptarmigan overall represented than there is willow ptarmigan. So what does this all mean? First of all, looking at the skeletal part representation at the site, I think we're looking at differential deposition during butchering and consumption stages. And my bet would be that we're either seeing a late stage of butchering and or waste after human consumption of these bones. And this is based off of the absence of the axial skeleton and the underrepresentation of the lower distal limb elements, as well as the underrepresentation of the shoulder girdle. This could potentially be explained by preservation bias due to bone density. However, with elements like the tarsometatarsus, there really isn't many big differences between that, the bone density of that, and other elements that are represented in the assemblage. Excavation bias may play into the recovery of some small elements like phalanges, but again, with some of those larger elements that are missing, like the tarsometatarsus, it doesn't quite explain the absence. So what I assume is to be happening is that a lot of the wings and part of the leg bones were being disarticulated from the rest of the body of the bird at a different area kind of outside of the excavation boundaries. An alternative hypothesis to this as well, though, is that those elements may have been given to the dogs to eat. And it's possible that if that is the case, that they would have been completely digested by the dogs. And so we would not have any evidence of them at all either, which is another viable hypothesis. When looking at the butchering, we do have evidence of both dismembering and filleting. Dismembering does appear to be happening on the wing, separating it from the main trunk of the body, as well as where the femur meets the axial skeleton, and potentially where the femur and the tibiotarsus articulate. And filleting is most notable on the humerus. And then, like I said, with on the osteometric study, archaeologists can distinguish between the two species of ptarmigans, but only using the leg bones, not the wing bones or shoulder girdle. So there really actually is no true size difference between the two species. It's just a difference in the kind of the lengths of their legs. And so this is important. I would recommend that if you have ptarmigans in archaeological sites, that you do use just only the femur, the tibiotarsus, and the tarsometatarsus. It's best to stick with the greatest length. And if you can use the tarsometatarsus, that's the best bet. However, in our assemblage at Palangana, that shows that the tarsometatarsus is so underrepresented. So we didn't have enough to get as much species data as we would have liked. And then, but what this does show us is that the Nunamiut were hunting both species with more of a bias towards rock ptarmigan, which is interesting because it suggests that they would have had to travel to higher elevations in order to hunt them. And another interesting observation, again, is that the rock ptarmigan that we have in the archaeological assemblage is smaller than that from the modern comparative collection. And this could probably best be explained by the fact that the modern comparative collection came from regions all over Alaska, including the Aleutian Islands. And so there could be size variation between different regions that may be influencing why the modern look slightly larger than the archaeological specimens. I did check, and there was no sexual dimorphism between males and females within the modern collection. So I don't believe that's what is driving kind of the size difference that we're seeing. But in conclusion, all of this shows that ptarmigans were an integral resource and part of daily life for the Nunamiut at Palangana and would have been a crucial resource during wintering months. And so with that, I want to thank my wonderful Master's Committee for all of their guidance and feedback throughout this research, including Dr. Mary Steiner, Dr. Steve Kuhn, and Dr. Francois Lanoy. I want to thank the University of Arizona School of Anthropology and Arizona State Museum for funding a lot of this research. I also want to thank Josh Ruschelther, Kevin Winker, Jack Withrow, and Angela Lynn at the Museum of the North for letting me visit to measure the comparative collection, as well as helping point me in the direction of the ethnographic literature. And then finally, I want to thank Diane Tank, Karen Price, and Lauren Puka at the Maxwell Museum of Anthropology in Albuquerque for letting me visit to look at the technological artifacts from Palangana, as well as old excavation archive notes. Thank you.
All right. Thank you, Miranda. That was great. Very thorough. So I'm going to move us right along to the next presentation. I've given Caroline co-hosting abilities, which means you can share your screen. Does anyone else need that as well?
Will you share that with Nicole? She's the one sharing the slides for us.
Oh yeah.
We're co-presenting.
Thanks.
Yep. All right, so let me introduce our next presenters, Caroline Funk, Nicole Misarti, Lorrie Rea, and Julie Avery, with a talk entitled The Long History of Mercury and Aleutian Marine Food Webs, Year 2 of the Aleutian Mercury Dynamics Project. So go ahead and take it away.
Hey, yeah, thanks a lot. Good afternoon, everybody. Today, Nicole Misarti and I are reporting on year 2 of our 5-year Aleutian Mercury Dynamics project. We're going to talk about the project, our progress so far, and some exciting new science developments, emergent patterns in mercury levels in ancient eastern Aleutian sea mammals, and an intriguing cod situation that's developing in the Rat Islands. And with this presentation and throughout the project's duration, we deliberately and intentionally invite comment and contribution from Ananga community members and anyone else with collaborative interests. Next slide, Nicole. The lead members of the research team are Julie Avery, Nicole Misarti, Lorrie Rea, and myself, and we share a common interest in identifying long-term patterns to form understandings of current cultural, environmental, and ecological situations, and in modeling future outcomes. I specialize in the culture-focused archaeological research aspects of this, including the zooarch. Nicole focuses on environment and ecology through chemical analysis of faunal materials. Julie and Lorrie focus on patterns in historical and contemporary sea mammal health and well-being. The work on this project is performed not just by the 4 of us, but with a large laboratory and scientific support staff comprised of professionals and graduate students, and the expert contributions of our diverse partners. Everyone's listed here, so you know who they are. We're really grateful for access to the faunal assemblages from the many Anangan archaeological sites in the study. We specifically thank the Ananga organizations who have granted us this access. Next slide, Nicole. So to briefly summarize our study's context, mercury is one of the top 10 contaminants of concern for human health, and chronic exposure to even low doses of mercury can have long-lasting effects on individual members of a population and on broader scale population dynamics. Mercury is also a contaminant of concern for other members of our ecological communities, and in our study, we focus on analyzing archaeological and historical samples from 3 sentinel species: cod, sea lions, and fur seals. So our project takes a coupled and dynamic perspective on mercury in the history of Aleutian food webs. On the one side, mercury is present in our world, and it always has been. And if this is so, high level of mercury should be identifiable in archaeological faunal bone through the 4,000-year span available with Ananga midden materials in the Aleutians. Or perhaps mercury is new to the Aleutian Islands. If mercury accumulation in the sentinel species is an anthropogenic phenomenon, we expect to find high mercury levels in post-industrial faunal samples, more or less exclusively. But the most likely coupled perspective and our operating model is that mercury has always been present in the Aleutians, with recent increased accumulation. If there are high mercury levels in periods associated with natural inputs, but no past oscillations approaching high modern levels, then mercury dynamics in the Aleutians might currently be experiencing synergistic amplification of anthropogenic and naturally derived mercury. Not awesome. Naturally derived mercury comes from permafrost, in some cases, perhaps, and in past warming periods and the subsequent flows of permafrost sediments into northern waters, there would likely have been an influx of mercury into ocean ecologies. In this case, we'd expect to see cycles of rising and falling mercury levels in our sentinel species that follow warmer and cooler temperature climate regimes. Naturally derived mercury also comes from volcanic emissions. These can contribute inorganic mercury to the atmosphere and oceanic systems. And of course, now industry deposits significant mercury into our global systems. We, in the study, predict that the mercury content of top predators, our sentinel species, will vary in cooler versus warmer climate regimes and in tandem with local scale and larger scale volcanic eruptions. Nicole, you're up.
So we chose to analyze samples from 3 species: stellar sea lions, northern fur seals, and Pacific cod. These species were chosen for 3 reasons. 1, there are changes in at least one of them that have been traced over the last 10 years, and that was actually the impetus for this proposal. 2, these are species of importance historically and in 3 ways: subsistence, culture, and commercial economics. These are also long-lived, high trophic level predators. So this is important for 2 reasons. They bioaccumulate mercury, meaning each individual accrues mercury over its lifespan. The longer you live, the more potential mercury uptake. And they're higher up the food chain. So biomagnification is also taking place as mercury transfers up the food chain and results in a higher concentration at the top. Those of you that know me won't be surprised that we're sampling bones from each of these species. These bones come from historic museum collections or from archaeological collections, most of which have been archived in museums. Bone is amazingly well-preserved tissue and can yield a lot of biological, ecological, and physiological information. In fact, the more we discover about what bones can tell us, the more grateful I am that I work in a place that has such incredibly well-preserved middens. It is truly exciting to be science to be a part of, and our entire project is very appreciative that such amazing collections exist and that we've been granted access to them by the UNANGA organizations. In this case, bones are doing quadruple duty in the science world. In the mammals, they'll give us 2 types of stable isotope data, both bulk and compound specific amino acid, as well as 2 types of mercury data. One bit from the compact bone that accumulates over many, many years, and 1 set of data from spongy bone, which yields a shorter history of mercury, most likely from the last couple of years of an individual's life. In the fish, they do a slightly quadruple duty. The bones are yielding an estimated size of each fish, the bulk and the compound specific amino acid stable isotope data, and 1 set of mercury data. Your bioaccumulation, your biomagnification. Caroline.
All right, I love that illustration. So the next slide. Like everybody else, we've had to adapt our research agenda to the ongoing pandemic conditions, which are easing here in New York anyway, but thankfully we were able to take advantage of 2 windows of opportunity for travel and access to collections in the past year. In July, Nicole and I visited the Museum of the Aleutians to sample materials from Unalaska, and we were there for 2 weeks. And in January, I was able to travel to Fairbanks to sample materials from the Rat Islands and Bull Deer. And while that sampling is critical to the data pipeline in our research program, it was also the first time a large number of our research team was able to meet up and work together. And this is a significantly collaborative project. It was awarded after the pandemic started and the global shutdown began, and we've been making it work, but it was really energizing and exciting to get together and work together in the lab as we had always intended to do. And hopefully that'll continue in the next few years of the project. Next slide. As we work through the archaeological materials for more than 50 years of excavation history across 700 miles in space, across multiple ancestral Unanga culture contexts and 4,000 years of cultural practice, we're witnessing a fascinating diversity. And some of this diversity is unsubtle. It manifests pretty clearly in the middens of Unalaska and Amchitka. And as you can see on the left here, the Unalaska midden samples are sorted, cleaned, and frankly, they are enormously fishy. They range from, they're from large ancestral village sites. They were excavated in massive personnel efforts, and the excavations were within a truck ride of their eventual museum home. On the right is an unsorted column sample from a 1969 near emergency level excavation on Amchitka Island prior to the Cannikin tests. This sample, everything excavated this far west, results from a small scale, enormously effortful short-term field program in a largest village that takes place a skiff ride, a boat ride, and several plane rides from its eventual museum home. So these differences impact our sampling. Right now, because half the research crew have ecology and biology backgrounds, we're quantifying this in terms of catch per unit of effort. So the number of samples we can include in our pan-elution study is going to vary across time and space, and we have to frame and quantify this variability for our interpretive modeling. For example, the catch per unit of effort ratio for the Rat Islands is far lower than for the Fox Islands. Next slide. So far, we've acquired 1,157 cod, sea lion, and fur seal bone samples for this study. We're working our way east to west, in part because the eastern materials have been available to us during the pandemic, but in part because this is a very satisfying approach. It's going to allow us to develop and compare temporal patterns in neighboring spaces as we progress. Our goal is to have, if possible, 10, 20 would be awesome, 10 samples of cod and 10 samples of Atarids for 250-year periods in each Aleutian Island group. And we thought this really sounded like an achievable plan because we're able to work with assemblages from any site in a given island group to fulfill that sample bucket list. It's challenging, actually, in fact. You might note that Snack and the Fox Islands have the largest number of samples on this chart. And since we more or less filled the sampling time buckets, we're moving on westward. We sampled heavily from the Rat Islands in January. And this is when we realized that the catch per unit of effort indicated a real pattern in cod abundance, and that regionally specific ancestral Unanga activities are going to impact our sampling strategy, particularly with the fish. After about 4 days of concentrated sampling effort by 2 people focused on fish midden materials in Unalaska, we stopped at 536 right side cod premaxillans. The cod were so numerous that we actually limited the number we sampled per provenience per stratigraphic level. And after 10 days of extremely intensive sampling by 3 to 5 people focusing on midden materials from the Rat Islands, we acquired 84 cod bones. Next slide. It occurred to us that this was unexpected, and it led us to our first exciting science news for today. We know that fish lenses are normal in village midden sites, and we expected to have the easy abundance of cod throughout the archipelago. We expected to confront differences in otarid representation more frequently. Confronted with the significantly fewer cod in the rats, we hypothesized, sitting in the lab, that the Rat Islands region just simply had lower cod populations than the Fox Islands. According to modern cod surveys, however, that is only a little bit true. Thompson and Paulson report cod hotspots around Unalaska, but also cod very warm spots in the Rat Islands. And the chart's not loading on my screen. There we go. So cod should be in the Amchitka middens if we can assume some consistency in cod populations through time. We have to hypothesize that Cahoon, Rat Islands, ancestral Unanga were not fishing in the same way that folks in Unalaska were. There could be a lot of reasons for that: economics, politics, demography, general difference in ways of doing things. But the cod situation we're seeing reminds us that all of our data in this research program are based in culturally mediated material records of past daily lives. We're learning a lot more about the diversity in Inangan histories as we work through this study. Nicole.
All right, so our sampling strategy, as we mentioned, we're looking at 3 species: sea lions, fur seals, and Pacific cod. We also need to access individuals, so we can only use MNI, so minimum number of individuals, not NISP, unfortunately. And yeah, we are destructively sampling. We're doing this using small Dremel saws to cut about 4 to 5 grams of bone from each individual. That's enough bone for us to generate enough collagen for both the bulk and the compound specific amino acid analyses, as well as to analyze 2 portions of each bone for mercury. The G and the compact get run separately since we're looking at these as separate types of data. As you can see from these pup bones on the left side of your screen, our sample size is actually not large to get all of those different types of data. For the fish specifically, we're collecting cranial elements with a preference for premaxillas on this project. We are measuring those fish cranial elements and you are using already well-established regression equations for each measurement to generate the size of an individual fish before subsampling for each type of analysis. So that's just one of those pieces of data from a single bone that I've mentioned before. We're generating a large number of samples and a huge amounts of data. And so we have a really busy sample pipeline from identification to database input to moving samples from one lab to the next. So everything is sort of triple bag labeled, bags, tags, spreadsheets, goes into an Access database as well. And then we have a whole nother pipeline of the data generated in the various wet labs and then on the instruments. So we are juggling a lot with these samples. So some more science. As our last few slides have shown you guys, we're just madly collecting and preparing samples still at this point in the project, but we're also conducting instrumental analyses, and we've actually begun to get a little bit of this data in hand. So this slide's just a sneak preview to show that there do appear to be fluctuating levels of mercury in the past. It's also obvious from this graph that the data we have so far don't really seem to fluctuate with large-scale climate change. Whether it's warm or cold doesn't really seem to matter. However, we do have an individual with really high mercury concentrations around 3,500 BP. And remember that Caroline told you we would have a second potential fun science moment, and this is it. So that individual with high mercury concentration coincidentally lived just a little bit after a recorded volcanic eruption that was large enough to show up from the same island. This is dated about 3,700 BP. I can't wait to see what other individuals from this area who lived within this time frame might show. So we also had another science puzzler. We looked at the nitrogen and carbon stable isotopes for these same samples. And interestingly, despite the fact that we believe stable isotopes of nitrogen, which are related to one's place in the food web, would be an influential factor in our study, thanks to that biomagnification that I described earlier, we did not find that in our data so far. It's early days yet, it's a small sample set, but it is very interesting. However, what we did find is that the concentration of mercury in sea lion and fur seal compact bone is associated with stable isotopes of carbon when you're grouping it within these 9 time periods. This can be due to changes in foraging location. Did they forage near shore versus offshore, or bottom-up driven changes in growth rate and productivity of the primary producers at the bottom of their food web. Bottom-up changes usually actually are driven by climatic and ecosystem change, and changes in foraging location can be driven by a number of different factors that aren't always tied to climate and can be tied to things such as human hunting pressures, etc. So one of our next steps is to analyze our samples using compound-specific amino acid stable isotope analyses, and these will help us to tease out the drivers of the patterns that we're finding. This type of analysis lets us get to whether or not it's bottom up or top down, or perhaps both, that affected the changes that we're seeing in these systems. So science often yields the unexpected, and we just have to look at that as the fun part of our work. But we're definitely looking forward to the data coming back from our larger data sets in the next year or so. So speaking of the next year, what we're planning is to increase our number of samples from the central to western Aleutians, to complete our archaeological fieldwork on Agatu Island. We want to catalog and ID the new collections that we bring back from Agatu. We're hoping to continue instrumental analyses of mercury and bulk stable isotopes, start our compound-specific amino acid analyses, and continue to share our results with scientific and local communities. So how we're sharing our science has been in multiple ways so far. We're trying to keep community scientists and others interested stakeholders up to date, part of which we're doing through our website. On the website, we have blogs we put up every month, and they reflect either what we're up to right at the moment, so in the moment science, or some are more informational about how we might use a particular set of data. We post announcements about our presentations, and we put any links about the project that we have come up with in the news. More importantly, with that little bit of travel that we've managed to do, we have interacted with folks on the ground and within the communities. We participated in Culture Camp in July and August, which was really fun. And not only introduced the youth to field archaeology, but we also got to bring them into the lab on rain days and get them sorting piles of bones and show them what that sort of back of the museum type of work might look like. We've interviewed on local radio shows and worked with NPR folks to generate a podcast that was broadcast statewide. And of course, we've presented at several scientific conferences, and that's covered disciplines from marine science to health to marine mammals and archaeology. And we're hoping next year to do some of this in person as well. So with that, we want to thank everyone. We want to thank the many tribal and native corporation entities that have so far granted access or collaborated with us in this project. We also want to mention again that we are deliberately and intentionally inviting comments, thoughts, and contribution from Inanga community members, as well as others who might have collaborative interests or something they think that they just want to talk about. We're aiming for that open communication along this entire research journey. And it has been a journey because we are so interdisciplinary within this project. And so we're inviting you once again to take a look at our website. The email or the website address is here. There's an email address for the whole project you can collect, that you can connect to us with. That's kind of a long web address right now, but if you just Google Aleutian Mercury Dynamics Project, you'll find us. So thanks again for listening, and we'll take any questions if we have time left.
All right, thank you. Well, we are in the break now, so there is time for questions for any of the four presenters that went during this session. And so I'm gonna see if there are any questions that come up. Okay. If not, then I'm gonna say let's take our break until 2 p.m. and then we'll come back for our last presentation in this session by Sean Teeter. So we'll start back up here in about 3 minutes. All right, is Sean on here, and do you want to get your PowerPoint shared?
Yep, I'm here. Volume okay there?
Yeah, it sounds good to me.
Okay.
So while you're getting that set up, I'll introduce you. This is our final presentation in this session, the Contributed Papers in Archaeology 2. We have Sean Teeter presenting a paper entitled Preliminary Results of the 2021 Data Recovery Mitigation for the Sterling Highway Realignment within the Squilantnu Archaeological District. And you may start when you're ready, Sean.
All right, well, thanks everyone for sticking around for the last presentation here. So I'd like to start by acknowledging that the Sterling Highway project is on the traditional lands of the Dene Athabascans, and thank tribal members at KIT and Theory that have collaborated together with us on this project. And so today I'm going to provide you all with an update on the progress of archaeological data recovery work that is ongoing as mitigation for the Sterling Highway project. Data recovery started last summer during the 2021 field season, and work is anticipated to continue this coming season. So I'll start by orienting us to the project area. I'll provide an overview of the spatial extent and chronology of the Squilantnu Archaeological District, and then we'll look at individual sites that were investigated last year and what some of the preliminary results were, although analysis is sort of just getting started. And I'll also touch on our experience using freely available 3D modeling software to document sites at the feature level, and talk a little bit about our experiences identifying and working with archaeological birch bark. So first of all, where are we? The area that we're working in is on the northern Kenai Peninsula, west of Cooper Landing, and centered at the confluence of the Russian and Kenai rivers. This area has been investigated archaeologically starting in the late 1970s, first as a result of 14H1 claims, surveys, and highway improvement projects. And this concentration of sites has been designated as the Squilantnu Archaeological District, the word Squilantnu being the Dena'ina place name for the upper Kenai River. And the district boundary is about 10 miles east-west to give people an idea of scale here. And the district contains over 100 prehistoric or traditional sites, and thousands of individual archaeological features have been mapped in the area, especially in proximity to the Russian River confluence. So the abridged chronology of the Skeletonu Archaeological District. There are basically 4 archaeological cultures that are known in the district, the earliest of which is a core and blade culture thought to be associated with the Denali complex. This is known in the district from the Round Mountain microblade locality at Kenai 94. The site is assumed to date from roughly 7,000 to 10,000 BP based on artifact typology and site stratigraphy, but not direct dating. And evidence of the northern archaic culture in the Skeletonu district and in Cook Inlet is limited to a single notch point at Seward 214, dated to roughly 4,000 BP. Rivering catchment sites. This culture is most well known from the lower Kenai River, but has been verified at least 2 sites in the district. And these sites are known to date from about 3,000 to 1,000 BP. And then late prehistoric sites, including Denina sites, are the most abundant site type in the district and can be verified most readily by their association with distinct house depressions with large rectilinear primary rooms and smaller ancillary rooms. And then, so of course, there are other archaeological cultures known from around Cook Inlet, but they have not been verified in Skeletonu as of yet. So the Sterling Highway project is a large undertaking. It involves construction of 8 new miles of highway that travel around Cooper Landing to the north, as well as several additional miles of on-alignment improvements. And in the process, these road improvements are unable to avoid several archaeological sites, resulting in an adverse effect under Section 106. Those effects are being mitigated through a PA between SHPO, the Forest Service, U.S. Fish and Wildlife, Kenichi Indian Tribe, SERI, Alaska DOT, FHWA, and the ACHP. And so far, archaeological data recovery has focused on the project's west end, involving testing and excavation at 6 sites. These include Kenai 738, 91, 741, 742, 215, and 746. But today I'm going to focus mostly on results from site Kenai 215. It's kind of hard to focus on a larger number of sites in detail. And I think that since all the sites investigated thus far exhibit some commonality in their surface level feature morphology, focusing on 215 will provide a good overview with where we're at other sites as well. So here's a location map of Kenai 215. And I just want to spend a little bit of time here talking about the site on a landscape level, and then look at the distribution of features at a few other sites in the area. The area that we're looking at is a little less than half a mile from the Russian River confluence. This map shows all the mapped late prehistoric house depressions on the north side of the Kenai River within 500 meters of Kenai 215. And we can see that they are all somewhat evenly spaced along terraces above the Kenai River, typically separated by 100 to 200 meters as single house depressions or in small groupings. And this is not to imply that other residential structures in the area don't exist in subsurface context, but this is what we see at the surface level. And several of these houses have been dated through previous work to have 19th century components, while at the same time, Kenai 94, which is represented by in this map by the house depression feature directly south of Kenai 215, also contains the Round Mountain microblade locality, which is the oldest known site in the district. So if we kind of zoom in on one of those sites, in this case, using Kenai 68 as an example, we see a large number of surface depression features surrounding a house depression in a somewhat random seeming pattern. And these pits include a large range of variability in size and shape, and connotate probably a large number of functions as well. So this is a pretty good example of a typical late prehistoric site layout in the Scalantnu district. And so, this contrasts pretty starkly with a commonly seen village layout at earlier riverine catchmack sites from the lower Kenai River, where we often see a row of single room house depressions adjacent to the riverbank. The location and layout of these sites has been discussed by Boras, who theorized that site locations were used to maximize drift net fishing opportunities. So, this sort of archetypal site layout for riverine catchmack sites is not something that has been observed in survey reports on the upper river in the Scalantnu district, but it does give you a sense of the site typologies that can be potentially interpreted at the surface level when looking at surface depression sites along the Kenai River. So, we can get an idea of chronology, potentially ethnicity, and functions of different features. So outside of the representative feature distribution seen at riverine catchmack and late prehistoric sites, there are many, many sites in the Scalantnu district that consist of surface depression features absent clearly identifiable associated house depressions. And so Kenai 215 fits this pattern. Although we're very close to sites on the upper terraces where a number of late prehistoric house depressions have been observed. And so when I said earlier that 215 is representative of other sites that HDR has been excavating in 2021, what I meant is that they also consist of surface depression features absent of clearly associated houses. So that's the larger context for the site. The site was recorded first in 1986 by OHA archaeologists and resurveyed and mapped again by OHA in 1989 and then HDR in 2020. The site topography we can see includes a small freshwater creek that runs through the site west of center. And we're situated here in a sort of basin-like terrace at the toe of a steep hill slope. And the alignment of the old Sterling Highway runs by the site on the south. So there are 11 surface depressions at the site. They're generally elliptical or circular, range in size from less than 1 meter to approximately 5 meters on a long axis. And a chipstone locus was identified by OHA archaeologists on the east side of the site during testing in 1989. So here's our excavation plan for 215 up to this point, showing excavation units, blocks, test pits, and features. We placed 278 test pits on a 4-meter staggered grid, and we did identify a midden on the west side of the site. However, all the excavation work conducted in 2021 was focused on the east side of the site, so we'll zoom in on that here. We placed 38 excavation units in 2021, 16 of which were positive for faunal remains or chipstone. We have 2 areas of block excavation, and so far we've tested or excavated 6 of the surface depression features. and there are 2 untested surface depression features remaining on the east side of the site. So looking at block 3, the placement of this block is at the location of the chipstone locus and possible hearth identified during testing in 1989. It's a 10 meter by 12 meter block where we've so far excavated 11.5 units, and we've so far been unable to identify the hearth, but we have found flagging tape with Sharpie on it from 1989. So in case anyone is wondering, Sharpie can survive in acidic soil for at least 32 years. So, the assemblage so far recovered in this area consists primarily of late stage reduction flakes. There's lots of pressure flaking apparent in the photos on the right. There are a variety of material type represented, including chert, chalcedony, and quartzite. And, a blade-like flake may be up in the top center there. And another aspect of the block 3 assemblage is some apparent heat treating, evident through pot lidding, both in flakes and in the small set of tested cobbles. And interestingly, one of the tribal observers that we were working with last summer informed us that this is material that can be found on Kenai area beaches, giving us a possible clue on lithic sourcing. But so far, characterization of this assemblage has been hampered by lack of associated datable material. There are no diagnostic artifacts, and there's a somewhat even distribution of artifacts through the soil column here, which we think might be the result of churning sediment at the base of the hill slope. So it's been difficult to isolate stratigraphically, but we'll likely learn more here as work continues, and we're very hopeful that we'll relocate that hearth from the 1989 work. This is feature D. It's roughly 10 meters north of block 3. It's a small surface depression feature that we bisected in 2 50-centimeter wide units. We found birch bark lining at the base of the feature, and so we expanded the excavation to fully expose the bark lining. So this birch bark was found to form a semicircle at the base. It's very badly decomposed, and the bark was found atop gravel and glacial till. So if we think about birch bark in archaeological and ethnographic contexts, we often associate it with caching or cache pits. We know that caches are typically found near villages or house depressions. They often are found along overlooks or on terraces, in areas of well-drained soil, near rivers and lakes, at seasonal camps, and they can sometimes be located at a tolerable distance for walking from house features. So if we think about these characteristics of caching behavior at Kenai 215, I think that many of them hold true, at least at a cursory level. The site is located near a number of late prehistoric house depressions, high on a terrace overlooking a major salmon-producing river and well-drained soil. As I said, this feature was dug into gravel or great glacial till, and it would appear to be a short walk at a remove from these known house depressions in the area. Another interesting thing about the excavation of feature D has come from the results of patient samples. So the individuals we have working on this have found a number of earthworm cocoons, as well as beetles. And unfortunately, I don't have any photos of the beetles that have been identified, but depending on the species of beetle in particular, this could give us an insight into what types of things may have been stored in cache features. As we have to remember that caches are not just for storing salmon, but other types of meat, furs, and various other items. So we are aware, of course, that beetles and worms burrow, but depending on a number of factors, it seems it could be an interesting avenue of additional research. So moving north from feature D, we can take a look at feature B and provide some initial interpretations. On the map here, we have features B, C, and G. G was not tested last summer, but B and C have produced positive results, including chipstone and faunal bone. And our initial basic interpretation of this is a storage feature that's been excavated into a previously existing midden. So if we look at the feature profile, the east wall feature profile, we can see a clear cut line. The base of the feature ending in a couple of distinct layers of dense gravel or reworked glacial till, as well as these layers of thick cultural fill on either side of the profile that's composed of a high quantity of ash, lots of charcoal, and some dense concentrations of faunal bone. So it'll be interesting to attempt to establish a chronological relationship between the fill that we can see on either side of the profile and the depression that has been excavated into it. Then I did want to touch on our use of photogrammetry techniques at this phase of field work. I think many of us are aware of the use of photogrammetry on an artifact or object scale, but we did find success with photogrammetry from the perspective of feature level documentation using the freely available application Mushroom. It's an open source program that creates 3D models from photographs using a modular pipeline. We took photos at 20-degree intervals for a 360-degree total. And ideally, these photos would be taken from a tripod. However, in the field, we used a position on the photographer's body as a reference point. So this process allowed for only minor changes in elevation and angle of the camera, which did not seem to hinder the software's ability to create the model. So photos were then loaded into Mushroom, which uses a predetermined process to identify the sensor and position of each photo. I was happy with the result. I think it creates a nice visualization for the things that we're doing in the field. And I do have to give a little shout out to Paul Howard of Scarcella, who helped us out a lot in processing those images.
So I just want to let you know, Sean, we are at, oh, you're done. Well, we're at time, but yeah. Great.
Oh, okay. Yeah, so I guess that's about it for today. Thank you all for your time, and we're looking forward to getting deeper into the results of excavations at this and other sites as analysis and more work continues. Thanks.
Okay. Thank you, Sean. Are there any questions for Sean real quick before we end our session here? All right, well, thank you everyone for coming out to the conference virtually and to this session. There is one final thing on the agenda for those who are interested. There's the business meeting happening in about 40 minutes in Zoom room A, which is not this room, it's the other one. Yeah, so just thank you all so much for your attention, for the presenters. Thank you so much for your work and for sharing it with us. And I hope that we see each other again soon and hopefully in person.